Hello there, and welcome to the Drift to the Stars. I'm so glad you found your way here tonight. Wherever you are right now, lying down, wrapped in something warm, letting the day finally loosen its hold, you are exactly where you need to be. This is a place of slow, curious wondering. No rush, no urgency. Just the quiet pleasure of learning something true about the world, and feeling, perhaps, a little more at home in it. Tonight, we are going somewhere most people never think to look. Not up into the sky, but down, into the ground. Into the frozen, ancient, impossibly patient earth that has been holding its breath since before the first human being ever looked up at the stars and wondered what they were. We are going into the permafrost. And just before we begin, if these calm, curious explorations help you unwind, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, if you're ready, let's begin. There is ground on this earth that has not thawed since mammoths were alive. Not ancient in the way a grandmother's story is ancient. Not old in the way a crumbling building is old. Ancient in the way that makes the entire span of human civilization feel like a single breath drawn and quietly released. Beneath the tundra of Siberia, of Canada, of Alaska, the soil has remained frozen without a single interruption for tens of thousands of years. The mammoths roamed above it. The great ice sheets advanced and retreated above it. Every human empire rose and fell above it. And through all of that, the ground simply held, still, cold, patient, beyond any patience we have words for. Scientists call it permafrost, a name that sounds almost ordinary for something so quietly extraordinary. It is not rock, it is not ice exactly. It is soil, sediment, ancient organic material, all bound together by cold into something that has resisted change longer than our species has existed. Even as you rest right now, it is there, holding. In the dark, far to the north, the ground is simply, gently, being still. Stillness like that has a weight to it, a comfort. The world has been keeping things safe for a very long time. Something lives inside that frozen darkness. This is the part that asks you to let go of what you think you know about life, about what it requires, about how little of it can survive without warmth and light and air. A single handful of permafrost soil, brought carefully to the surface, contains more living bacteria than there are stars visible in a clear night sky with the naked eye. Not dormant exactly, not dead. Somewhere in between, which is a place that turns out to exist, quietly, beyond the edge of what we imagine possible. These organisms slow themselves to a metabolism so reduced it barely registers by any instrument we have. They do not sleep the way you sleep. They exist in something closer to a suspension of becoming, waiting without knowing they are waiting, patient in a way that has no equivalent in anything we recognize as a life. They were there before the pyramids, before agriculture, before language, possibly. Sealed in cold, in dark, in silence so complete that even the concept of time may not apply to them the way it applies to you. And yet, when the warmth comes, they wake, they move, they resume. Right now, beneath northern soils, more lives than the night sky holds, stars are simply, quietly continuing. You are never as alone in this universe as the darkness suggests. The cold that holds those lives descends much further than you might imagine. Stand at the edge of the tundra on a clear Arctic day, and the frozen layer beneath you does not end at arm's reach, or knee depth, or even as far down as a house is tall. In parts of Siberia, the permafrost layer drops to depths greater than 3 Eiffel Towers placed end to end, descending into the earth, in total darkness, total cold, total stillness. Deeper than most minds have ever reached, deeper than daylight has ever fallen. And yet within that column of frozen earth, there is structure, there is layering, There are bands of material from different eras, compressed one on top of another across geological time, each one a record of a world that no longer exists on the surface. Geologists who drill cores from this depth describe a particular kind of ore, not the loud kind, but the kind that arrives quietly after you have had a moment to understand the scale of what you are holding. Each centimeter of that core took centuries to form. The whole of it holds more history than any library ever built, and it all exists, right now, in patient, frozen silence, far below the surface of the ordinary world. Depth, it turns out, is not emptiness. It is storage. It is memory. It is time, held in the form of cold. Among the most startling things ever recovered from that frozen depth is something that blurs every clean line between alive and not alive. Ancient viruses, sealed in Siberian permafrost for tens of thousands of years, have been carefully recovered by scientists and, under controlled laboratory conditions, restored to activity. Not harmful to humans, the researchers are clear about that. These particular ancient viruses seek only the single-celled organisms they always sought, following an appetite so old it predates every animal on Earth. But they wake, they function, they pursue. After 48,500 years of frozen stillness, they remember what they are. The number is worth sitting with for a moment, not as something alarming, but as something quietly astonishing about the nature of life itself and what it can survive. Nearly 50,000 years. And still, underneath all of that cold and dark and time, something persisted that was able to recognize warmth and respond to it. Scientists who study these recoveries speak carefully, precisely, aware that they are working at a boundary that biology had not previously mapped. What does it mean to be alive? Exactly. If life can pause for 50 millennia and then resume, the question is not frightening. It is, in its own strange way, deeply reassuring. Life, it seems, is more stubborn than almost anything. The universe tends to keep what it makes. Above the ancient frozen depths, the surface of the permafrost landscape does something that takes most people entirely by surprise. It breathes. Not quickly, not visibly if you watch for only a moment, but over seasons, over years. The tundra above permafrost rises and falls in a slow, enormous rhythm, driven by the freezing and thawing of the thin, active layer of soil at the very top. In spring, the surface lifts, pushed upward by expanding ice. In late summer, it settles back down as the warmth penetrates and the ice yields. Across a human lifetime, a single patch of tundra might rise and fall dozens of times, each cycle imperceptibly slow from day to day, but measurable across the years. This movement is called frost heave, and it shapes everything on the surface above it. Roads buckle, fence posts tilt, trees lean at angles that make a forest look like a crowd of people who have all, gently, lost their balance at once. From above, the tundra in these regions develops extraordinary geometric patterns, polygons and rings and lines pressed into the landscape by the slow, repeated motion of the ground itself. The earth is not static. Even in its most frozen form, it is moving, very slowly, very gently, always. The world has its own kind of breathing, and it has never once stopped. What the permafrost has kept is sometimes so intact it asks you to reconsider what the word preserved even means. Woolly mammoth hair, pulled from Siberian permafrost, has arrived at the surface, still soft, still carrying its original color, a warm amber brown that scientists were able to analyze at the level of individual pigment cells, the same cells that decided, tens of thousands of years ago, what shade of fur a particular mammoth would wear across the steppes of the Pleistocene. Not a fossil, not a shape pressed into stone. The actual biological structure of the hair, intact enough to study at a cellular level, intact enough to tell us that mammoths likely had two kinds of fur, a coarse outer layer and a soft, dense undercoat, built for cold in exactly the way you would engineer it if you were designing an animal for an ice age. The coldness that killed them, in the end, is also what remembered them for us. There is something in that worth sitting with gently. The same force that can take a life can also, under certain conditions, hold the memory of that life with extraordinary care. The cold is not cruel, it is simply indifferent, and indifference, sometimes, looks exactly like preservation. What is lost on the surface is sometimes kept perfectly below. The scale of what permafrost covers is easy to say, and surprisingly hard to truly feel. Roughly 1/4 of all land in the Northern Hemisphere sits above permafrost right now, tonight, while you rest. That is not a remote, abstract statistic about somewhere impossibly far away. It is the ground beneath cities in Russia, beneath villages in Alaska and Canada, beneath roads and airports and homes where people are, right now, sleeping in beds above ancient ice, the tundra of Siberia, the boreal forests of Canada, the high plateaus of Tibet, all of them underlain by this vast, cold, continuous frozen layer that connects, beneath the surface, regions separated by thousands of kilometers of open land. Think of it as a hidden continent, not made of water or rock in the usual sense, but of frozen time, pressed against the undersurface of the world we walk on every day without knowing it is there. It is the largest cold storage system on Earth, and it was here long before anything was ever deliberately stored in it. It formed on its own. It persisted on its own. It holds what it holds without any instruction from us. The world has been keeping its own records, quietly, without anyone's permission. Among the gentlest and most quietly astonishing things that permafrost has returned to the living world is a flower. The Silene stenophylla is a small flowering plant, modest in appearance, the kind of thing you might walk past on a hillside without pausing. Seeds from this plant, recovered from a Siberian permafrost deposit where they had been stored, possibly by an ancient squirrel filling a burrow for a winter that never ended, were carefully cultured in a laboratory. They grew. After 32,000 years of frozen sleep, they germinated, they grew stems and leaves, and they flowered. The flowers that opened in that laboratory had last bloomed during the Pleistocene, when mammoths grazed nearby and the climate was a different world entirely. Scientists compared the revived plant to modern Silene stenophylla still growing in Siberia today, and found small but measurable differences, tiny evolutionary distances, accumulated across 32,000 years of separate paths. The ancient plant was not identical to its descendants. It was its own thing, a visitor from a world we had thought entirely gone, blooming quietly under laboratory lights. No drama, no announcement, just a small flower, opening the way flowers do, because that is what it was made to do. Life does not know it has been waiting. It simply continues when it can. Inside the permafrost, sealed in tiny bubbles within ancient ice, is something that no technology could ever recreate. The actual air of the Ice Age atmosphere. Not a measurement of it, not a chemical reconstruction. The air itself, physically present, trapped at the moment the ice formed around it, and held there ever since, unaltered, unreacted, unchanged. When scientists carefully extract and analyze these bubbles, they are breathing, in a technical sense, the same atmosphere that a mammoth breathed, the same mixture of gases that moved through the lungs of animals that no longer exist, that blew across landscapes that no longer look the way they did, that was exhaled by forests and wetlands and ice sheets that have since retreated or disappeared. These bubbles hold the chemical signature of a climate that predates every human institution, every human language, every human memory. They are the most literal kind of record that exists. Not a description of the past, but the past itself, present in a laboratory, in a frozen core, pulled gently from ground that held it safe while everything else changed around it. Scientists call these samples irreplaceable, and they mean it with a precision that the word rarely carries. Some things are kept so perfectly that even time cannot find a way in. There is a place where the frozen land continues beneath the sea. Most of us carry a quiet assumption that the ocean floor is a different world entirely, wet and dark, and separate from the cold, dry land of the north. But beneath the Arctic Ocean, extending outward from the Siberian and Alaskan coastlines, the permafrost does not stop at the water's edge. It continues, submerged, ancient, formed during an era when sea levels were lower and that ocean floor was open tundra, walked by animals, blown over by wind, frozen by the same cold that froze the land beside it. When the Ice Age ended and the seas rose, the water covered the land, but did not immediately warm the ground beneath it. And so the permafrost remained, sealed now under ocean rather than sky, a frozen continent hidden below the water, extending across an area larger than many countries. Scientists study it with instruments lowered from ships, reading the temperature and chemistry of ground that has not been touched by air in thousands of years. It is among the least visited environments on Earth, quieter than any forest, darker than any night you have ever known, and still, in its own way, full of what the Ice Age left behind, full of carbon, full of cold, full of a patience so deep it has no human name. The world is larger, and stranger, and more continuous than its surfaces suggest. Every layer of permafrost is a page in a book that was never meant for us to read. Imagine pressing your palm flat against the frozen tundra and pushing gently downward, passing through layer after layer of compressed history. Near the surface, the material is relatively recent, centuries old, holding the remnants of vegetation and animals from a time that overlaps, at its edges, with human memory. A little deeper, and you are in a world before written language, deeper still, before agriculture. Further down, before the first cities, before the first domesticated animals, before the first deliberate fire. Each cubic meter of permafrost contains thousands of years of biological history, laid down one season at a time, each lay sealed by cold before it could fully decompose, each one preserving something of the world as it was at that particular moment. The compression is extraordinary. A core sample, narrow enough to hold in both hands, might span more time than the entire existence of our species, and it is all still there, still present, still readable by those who know the language of isotopes and pollen and ancient DNA. Not metaphorically, literally, the past is physically inside the ground, right now, waiting with absolute calm for whoever comes to ask it questions. You are living above a library that has never once closed. Among the qualities that make permafrost so unlike anything else on Earth is the precision of its definition. It does not ask you to feel how cold the ground is. It does not care whether it looks frozen from the surface. Permafrost is defined by a single, clear criterion: ground that remains at or below the freezing point of water for at least 2 consecutive years. That is all. 2 years. Which sounds, at first, like a remarkably short requirement for something that has lasted tens of thousands of years in some locations. But that definition is also what makes permafrost so conceptually clean, so honest. It is not asking to be ancient. It is simply asking to be cold, continuously, for long enough. And some of it has satisfied that requirement without interruption since the Pleistocene, since the time of the great megafauna, since before the last ice age reached its peak, simply by remaining exactly what it is, cold enough long enough, quietly enough. The definition does not change. The ground does not change. Only the world above it shifts and turns and races forward, while the permafrost simply continues to meet its single, modest condition, one frozen day at a time, without effort, without awareness, without any need for recognition. The oldest things rarely announce what they are. The bacteria inside permafrost do not sleep the way anything else sleeps. Sleep, as you know it, is a rhythm, a cycle, something that ends and begins again with reasonable predictability. What happens to microorganisms in deep permafrost is something else entirely, something that science is still working to find adequate language for. Their metabolisms, the rates at which they process energy, exchange chemicals, and maintain their cellular structures, slow to levels so reduced that some researchers have described the state as closer to suspended dreaming than biological rest. They are not technically dormant in the classical sense. Some of them continue to perform the most minimal cellular maintenance, repairing damage to their DNA at a rate so slow it might take years to complete a process that takes your own cells minutes. They are not waiting for anything. They have no awareness of time passing. They simply exist at the very lowest threshold of what existing can mean, somewhere between function and stillness, in a place where the boundary between alive and not alive becomes genuinely unclear. Scientists find this not alarming but deeply interesting. It suggests that life is not a binary condition. It is a spectrum, and at one end of that spectrum, in the frozen dark, something is always, barely, gently, continuing. Even at the very edge of existence, something holds on. The depth of Siberian permafrost is not simply a measurement. It is a kind of reckoning. In the Yakutia region of Russia, the permafrost descends to depths approaching 1.5 kilometers below the surface. To place that in terms the body can feel rather than the mind simply process, it is deeper than the height of 4 Empire State Buildings, stacked directly on top of one another. It is deeper than most commercial minds ever reach. It is deeper than any natural light has ever fallen, in any form, in any season, across the entire history of that landscape. And within that column of frozen earth, temperature changes so little across a human lifetime that scientists describe the deepest layers as among the most thermally stable environments found anywhere on the planet's land surface. Not a cave, not a bunker, not an engineered chamber, just the earth itself, cold and still and consistent, maintaining a temperature decade after decade with a reliability that no technology we have built has ever matched. The ground does not fluctuate. The ground does not vary. The ground simply holds its temperature the way it holds everything else, with a patience so absolute it becomes almost difficult to conceive of as a natural thing rather than a deliberate one. Some forms of constancy are so complete, they feel, quietly, like a kind of care. Inside the permafrost, there are forests that fell and were never allowed to rot. Not fossil forests, pressed flat and turned to stone across millions of years. Something stranger and more immediate than that. Entire ancient trees, their trunks still intact, their wood still wood rather than mineral, lie buried horizontally within permafrost deposits, frozen mid-fall from a climate that changed faster than the forest could adapt. These are trees that lived and grew and photosynthesized under a sky that no longer exists, in a temperature regime that has since shifted, in a landscape populated by animals that are now entirely gone. And when the cold came quickly enough, or when the ground swallowed them before decomposition could begin, the permafrost sealed them in place. Scientists have recovered wood from these buried forests that still burns, still smells like wood smoke when it does. The cellular structure of the timber is intact enough to identify the species, to measure the rings, to read the good years and the difficult years of a tree's life as clearly as you might read a page of text. The cold did not petrify them. It simply paused them. It held them exactly as they were, the way the world sometimes holds something precious without knowing that is what it is doing. What is kept gently enough is sometimes returned almost whole. The carbon held inside permafrost is a number so large it requires a different kind of approach to understand. Raw numbers tend to slide off the mind when they grow large enough. So set the number aside for a moment, and instead consider this. The amount of carbon locked in frozen form beneath the world's permafrost regions is roughly twice the total amount of carbon currently present in the entire atmosphere of the Earth. Not a comparable amount, not a similar amount, twice. All the carbon dioxide, all the methane, all the greenhouse gases currently circulating through the air above every city, every ocean, every forest and desert and mountain range on Earth, and then that same amount again, held still and cold beneath the tundra. It arrived there across tens of thousands of years, one season at a time, as plants grew and died and were sealed into the frozen ground before they could release their carbon back into the air. The permafrost became, without any intention, the largest carbon storage system on the planet's land surface. Not a vault anyone built, not a system anyone designed, simply the result of cold and time and the slow accumulation of everything that lived and fell and was kept. The Earth has been quietly balancing something enormous for a very long time. Among the animals returned to us by the permafrost, some arrive with a completeness that is almost unbearable in its tenderness. Cave lion cubs have been recovered from Siberian permafrost, with their fur still present, their facial features still defined, their whiskers still fine and intact. These are animals that lived during the Pleistocene, members of a species that has been extinct for thousands of years, and yet the specimens recovered look, at first encounter, as though they simply curled up somewhere warm and fell deeply, completely asleep. Their eyes are closed. Their paws are folded in the way a sleeping animal arranges itself. Scientists who first encountered well-preserved specimens have described a specific quality to that moment, a stillness in the room, a collective pause, because the animal in front of them did not look like an artifact or a specimen. It looked like something that might, if the temperature were slightly different, simply open its eyes. The cold preserved not just the biology, but the posture, not just the cells, but the particular arrangement of a body in its final rest. Something about that is not sad, exactly. Something about it is closer to a kind of grace. The world kept them so carefully that we can still see how they chose to sleep. Rest, it turns out, can be kept gently for a very long time. The permafrost is not simply a cold place. It is the only place. Everywhere else, what we know of ancient life comes to us as impression, as outline, as mineral replacement, the slow geological process that turns organic material into stone and stone into record. A dinosaur bone is not a bone anymore. It is rock that remembers the shape of a bone. A trilobite fossil is rock that remembers the pattern of an exoskeleton. Beautiful, yes. Informative, deeply, but translated, converted. Once removed from the original, permafrost offers something that no other environment on Earth provides. Actual biological material, in its original form, in 3 physical dimensions, chemically intact enough to analyze at the molecular level. Not the shape of a mammoth hair, the hair. Not the impression of a flower petal, the petal. Not a record of a virus, the virus, still capable of function. This distinction matters not just scientifically but in some quieter way that is harder to name. It means the past is not entirely past. Some of it is still here, physically present, held in the frozen ground, in the form of actual things, rather than traces of things. The archive is not a description of what was. It is what was, still here, still intact, still cold. Time, in the permafrost, is not a direction. It is a layer. There are forests in permafrost regions that tilt and lean as if the ground beneath them has lost confidence. They are called drunken forests, and the name, despite its lightness, describes something real and observable and quietly strange. As permafrost near the surface warms and softens, even slightly, even seasonally, the ground loses the rigidity that has been holding trees upright for their entire lives, and so the trees begin to lean. Not dramatically, not all at once, but gradually, each growing season adding another fraction of a degree to the tilt, until a forest that was once straight and vertical becomes a landscape of trees angled in many different directions, each one following the particular softening of the particular patch of ground beneath its roots. Seen from a distance, these forests have an quality of movement about them, as though caught mid-gesture, as though the trees were in the process of slowly deciding something. Scientists study them as indicators of subsurface change, reading the angle of the lean, the direction of the tilt, the pattern of which trees are affected and which are not, to understand what is happening in the frozen layer below. The trees themselves are simply doing what trees do, reaching for light, anchoring in whatever ground they have, continuing. The ground, for the first time in thousands of years, is beginning to shift beneath them. Even the slowest changes leave a record in the living things above them. Deep within the permafrost, ice takes forms that exist nowhere else on Earth. Not the ice of a frozen lake, flat and familiar and seasonally predictable. Not the ice of a glacier, moving slowly downhill in response to gravity and its own accumulated weight. The ice inside permafrost grows in shapes that have no equivalent in any other environment. Massive underground lenses, some of them the size of buildings, formed over millennia by the slow migration of water molecules toward existing ice surfaces, one molecule at a time, across geological time, in total darkness, in total cold. These ice bodies are not frozen water in the ordinary sense. They are structures. They have internal architecture. They have boundaries and gradients and orientations that record the history of the cold that formed them. Some of them have been growing continuously for thousands of years, accumulating size and complexity at a rate so slow it makes the growth of a coral reef feel hurried by comparison. And they exist completely out of sight, completely unknown to the surface world above them, exerting their influence only through the subtle way they shape the ground, the way they hold the soil around them in a particular arrangement, the way their eventual thaw leaves a collapse, a depression, a pond where solid ground once was. They are hidden architecture, the bones of a landscape that shows no bones from above. The most patient structures in the world are the ones no one has ever seen. What the permafrost returned to science in 1977 was not a specimen. It was a presence. A baby mammoth, now known by the name Lyuba, was found by a reindeer herder in Siberia, her body so completely preserved by the permafrost that the grass pressed into the mud around her final resting place was still identifiable by species. Her eyelashes were intact. The soft tissue of her trunk retained its structure. Scientists who examined her were able to determine not only what she had eaten in her last days, her mother's milk, still chemically traceable in her stomach, but the precise circumstances of her death, the particular way the cold mud had sealed around her within hours of her passing, beginning the preservation process before decomposition could take hold. She was approximately 1 month old when she died. She had lived during a world so different from ours that the landscape she knew no longer exists in any form on the surface of the earth. And yet she was returned to us with a completeness that made the distance between her world and ours feel, for a moment, navigable. Not a fossil, not an artifact. A small animal, softly kept, returned after 42,000 years with her eyelashes still fine and her last meal still present. The cold keeps what it takes with a gentleness that nothing else matches. The woolly rhinoceros recovered from Siberian permafrost arrived carrying something no excavation had ever returned before. Its last meal, still inside it, still identifiable, not as a chemical trace, but as recognizable plant material. Grasses and flowers from the Pleistocene tundra, preserved inside the animal's digestive system, in a condition detailed enough for botanists to identify individual species. Flowers that had not bloomed on the surface of the earth for tens of thousands of years were found, softly, inside the stomach of an animal that had eaten them on what turned out to be one of its final days. Scientists were able to reconstruct, from that single discovery, something of what the landscape looked like in that particular season, of that particular era, which plants were growing, which were in flower, which were available to a large grazing animal moving across the steppe. A meal became a window, a stomach became an archive, and the animal itself, which had lived and grazed and moved through a world we can now only partially imagine, had carried that world inside it, sealed by cold for tens of thousands of years, until the permafrost offered it back, not as a story, as actual flowers, actual grass, the real thing, kept perfectly, by cold and time and the particular mercy of the frozen ground. What is swallowed gently enough is sometimes kept long enough to be found. Among all the qualities of deep permafrost, the one that scientists return to most often is its thermal stillness. In the deepest layers, the temperature barely moves, not across seasons, not across decades. In some locations, instruments left in permafrost boreholes and checked years later show temperature readings so consistent they are difficult to distinguish from measurement error. The ground is simply that stable. This is not the cold of winter, which arrives and departs in its familiar rhythm. This is a cold that has been the same, within fractions of a degree, for longer than any thermometer has existed, longer than any civilization has kept records, longer than our species has been on this continent at all. Scientists describe it as among the most thermally stable environments accessible anywhere on the planet's land surface. More stable than a cave, more consistent than the deep ocean sediment. A place where temperature, that most restless and variable of physical properties, has simply stopped varying and has held its single value with a fidelity that no engineered system has ever matched for as long. There is something almost meditative about that. A temperature held without effort, without adjustment, without any awareness of holding, simply because the conditions that produced it have not changed, and so the temperature has not changed, and the ground simply continues to be exactly as cold as it has always been. Some things remain not through effort but through the simple absence of anything that would change them. On the surface of permafrost regions, something has been happening that takes the eye a moment to understand. Thermokarst lakes. They're called dark, shallow pools that form when permafrost near the surface thaws and the ground above the thaw collapses inward, filling with meltwater. From above, a thermokarst landscape looks like a vast, quiet puzzle of water and land. Pools of every size scattered across the tundra in no apparent pattern. Their edges soft and undefined, their surfaces dark and still. But look more carefully, and the stillness is not complete. These lakes bubble, gently, continuously. From their beds, methane rises in small streams of bubbles, released by ancient microbes that have awakened in the thawed sediment beneath the water and resumed. After thousands of years of frozen suspension, the slow process of consuming organic material and breathing out gas. Scientists collect this methane by placing inverted funnels over the bubbling spots and measuring what accumulates. They have found bubbles rising from material that was frozen and dormant for more than 10,000 years. The microbes did not know they had been asleep. They simply woke to warmth and resumed what they had always done. The lakes are quiet from a distance. Up close, they are breathing. Even the most still-looking surfaces, given enough patience, reveal what is happening beneath them. The discovery of gold in the Yukon was, in a quieter way than history usually tells it, a story about permafrost. The ancient creek beds that guided miners to their richest finds were not visible on the surface. They were buried, sealed, preserved beneath the frozen ground, their courses held in place by the permafrost that had sealed around them thousands of years ago when the climate shifted and the water stopped flowing. The organic material within those ancient channels, leaves and wood and animal remains from a vanished landscape, had kept the creek beds structurally intact, holding the shape of waterways that had not carried water since the Pleistocene. Miners who understood the ground learned to read these buried channels, to follow the frozen record of old rivers toward the gold that had settled in their ancient bends and pools. The permafrost had not just preserved biology, it had preserved geography. It had kept the shape of a landscape that no longer existed on the surface, holding it in reserve beneath the ground, available to anyone who knew how to ask the frozen earth what it remembered. The gold rush was, in this sense, also an act of reading, of following a map that the permafrost had been holding, patiently, for thousands of years. The earth keeps more than we think to look for. Sometimes the treasure is the record itself. Light has never reached the deepest permafrost, and yet the deepest permafrost is anything but empty. This is one of the things worth sitting with slowly. That light, which we tend to associate with life, with growth, with everything that seems vital and necessary, is entirely absent from a place that turns out to be among the most densely populated environments on the planet, populated not by visible creatures, but by microscopic ones, in numbers that exceed the visible universe in stars. The deepest permafrost exists in a darkness so complete that the concept of day and night is entirely meaningless there. It has experienced the same absence of light in winter that it experiences in summer, the same darkness at noon that it experiences at midnight, the same lightlessness during periods when the sun was shining brightly on the surface immediately above it. And still, within that permanent dark, life persisted. Metabolism continued, however slowly. DNA was repaired, however gradually. The biological processes that we associate with warmth and light and activity were, it turns out, also capable of occurring in cold and dark and stillness, just at a pace so different from anything we recognize as lively that we required instruments to detect it. Life is more flexible than light. Life goes where light does not. Wherever you find the conditions for patience, you find, eventually, something that has been waiting there. For centuries before scientists arrived with their instruments and their core drills, indigenous peoples of the North knew the frozen ground the way others know the weather. The communities of Alaska, Siberia, Canada, and Scandinavia developed knowledge of permafrost behavior across hundreds of generations of direct, consequential engagement with the land. They knew which ground was safe to build on and which would shift. They knew which slopes would hold and which would slump. They knew the particular sounds the earth made as it changed across seasons, the particular smells that preceded thaw, the particular visual signs in the vegetation above that indicated what was happening in the frozen layer below. This knowledge was not written down in most cases. It was carried in practice, in story, in the particular way a community chose to situate itself in a landscape, in the accumulated decisions of generations who had learned, through direct experience, how to read a ground that most of the world did not even know existed. Scientists working in permafrost regions today increasingly seek out this knowledge, recognizing that it represents a longitudinal record of landscape behavior that no instrument network can match. Observations accumulated across timescales that modern science has only recently begun to appreciate. The frozen ground was known, intimately and practically, long before it had a name. The oldest knowledge is often the quietest, and the least likely to announce itself. There is a smell to thawing permafrost that those who have encountered it describe with a consistency that is itself informative. Rich, dark, primordial. Those are the words that recur across different researchers, different nationalities, different regions of the permafrost world. The smell of organic material that has been sealed from open air for tens of thousands of years, suddenly released as the frozen ground opens and the ancient carbon within it encounters oxygen for the first time since the Pleistocene. It is the smell of decomposition, yes, but decomposition of material so old that the word carries a different weight than usual. What is decomposing is not recent. It is the remnant of a world that your great-grandmother's great-grandmother's great-grandmother could not have imagined, because no human alive at any point in recorded history ever lived in a time when that material was fresh, and now it is in the air, present, detectable by the most ordinary of human senses, the nose, without any instrument, without any training, simply by standing near thawing permafrost on a warm day and breathing in. The past has a smell. It arrives without announcement. It is, by all accounts, unmistakable. Some records do not need to be read. They simply need to be breathed. The oldest permafrost on Earth is not in the Arctic. It is in Antarctica, in the dry valleys, a region of extraordinary cold and extraordinary aridity, where the conditions have conspired to preserve frozen ground for a duration that exceeds the imagination in a different way than the Siberian permafrost does. The Antarctic dry valley permafrost may be more than 8 million years old. Not thousands of years, not tens of thousands, millions. It predates the genus Homo entirely. It was frozen before our most ancient ancestors had yet begun the evolutionary journey that would, eventually, produce a species capable of going there and measuring it. At that depth of time, the permafrost is no longer a record of the Ice Age, because the Ice Age had not yet occurred when it formed. It is a record of something older still, a climate state so different from anything in human experience or human history that the scientists who study it describe working near it as a kind of conceptual vertigo. The ground beneath their feet is older than the human story, older than the story of human ancestors. It was cold before we existed to feel cold, and it is cold still. Some patience is so deep, it becomes a form of permanence. Even in permafrost, that has remained frozen for 40,000 years, something moves. Not much, not visibly, not in any way that would register to any sense you possess without instruments to extend them. But in the microscopic films of liquid water that persist around individual soil particles, even at temperatures well below freezing, some bacteria retain the capacity for movement. The water does not freeze completely in these films because of the chemistry of the surfaces it clings to, the particular way mineral particles interact with water molecules at scales too small to see, creating a condition that is not quite frozen and not quite liquid, a third state that has no common name because common language was not built for it. And in that thin, dark, mineral-scented film of almost water, bacteria move, slowly, in ways that instruments can detect, but eyes cannot follow. They are not swimming, they are not searching, they are simply, at the most minimal level of biological possibility, continuing to be organisms rather than objects. Scientists who study these films describe them with a particular carefulness of language, aware that what they are observing sits at the very edge of what the word life can be stretched to cover. And yet there is no better word. In the frozen dark, in a film of water thinner than a human hair, something is moving. At the very boundary of what is possible, life finds the width of a hair, and calls it enough. In the Yukon, a forest is frozen in permafrost that was alive 3 million years ago. Not the Ice Age, not the Pleistocene. 3 million years ago, during a warm period that predates the Great Glaciations entirely, trees grew in what is now the Canadian subarctic, photosynthesizing under a sky that was warmer and wetter than anything that region has known since. When the climate shifted and the cold descended, some of those trees were buried and frozen before they could decompose, their cellular structure sealed in the permafrost that formed around them. Scientists recovered wood from these deposits and examined it under microscopes, finding cells still recognizable as wood cells, still showing the anatomical features that allowed identification of the species, still carrying enough chemical information to reconstruct something of the growing conditions those trees experienced during their lifetimes. The rings were still legible. The good years and the difficult years of trees that lived before our genus existed were still recorded in the wood, still readable, still meaningful to a scientist patient enough to look. 3 million years of cold had not erased the record. It had simply kept it in the dark, waiting for someone with the right instruments and the right questions to come and ask what the trees remembered. Memory does not require a mind. It requires only the right conditions for keeping. The nematodes of Siberia are perhaps the gentlest argument that science has ever made for the stubbornness of life. Roundworms, microscopic, unremarkable in appearance, found in permafrost deposits in northeastern Siberia, were carefully thawed in a laboratory and placed in conditions suitable for their kind. Warmth, moisture, the particular chemical environment their biology requires, and they moved. After 42,000 years of frozen stillness, they resumed locomotion. They resumed feeding. The researchers who witnessed this describe the process with the measured precision of scientists who are aware that what they are seeing is genuinely without precedent, but the precision cannot entirely conceal the quality of the moment, which was, by any honest account, quietly extraordinary. 42,000 years, and then movement, and then appetite. No drama, no visible distress, simply the resumption of being a nematode, which is what they were before the cold, and what they remained after it, unchanged in any detectable way by the entirety of human prehistory and history that had passed above them while they waited in the ice. Scientists still debate the precise mechanisms that allowed their survival. The worms, for their part, offered no explanation. They simply continued. Life does not explain itself. It simply resumes, when it can, and continues. From high above, the tundra surface over permafrost looks as though someone has pressed a vast geometric stamp into the earth. Polygons, hundreds of them, sometimes thousands, arranged across the landscape in patterns so regular and so large that early aerial photographers, encountering them for the first time, reported back the presence of what appeared to be artificial structures, enormous geometric earthworks of unknown origin and purpose. The origin is the permafrost itself, and the purpose, in the loose sense of that word, is the physics of freezing and thawing operating at landscape scale across thousands of years. As the ground freezes each winter and expands, and thaws each summer and contracts, the surface cracks along lines of weakness that become, over time, increasingly defined. Ice fills these cracks each winter. The ice wedges grow, gradually, over centuries and millennia, pushing the soil upward along their edges and creating the raised rims of the polygons. The centers settle. The pattern reinforces itself, season after season, each year adding a fraction of a millimeter to a structure that has been forming since before the oldest human civilization began. Seen from the ground, you would not know you were standing inside one. Seen from above, the geometry is unmistakable. The frozen earth has been drawing on itself for thousands of years, in a language made entirely of cold. The Earth makes patterns not to be seen, but simply because the physics of patience produces them. The quietest soundscape naturally occurring on Earth may be the winter tundra above deep permafrost. Sound requires a medium to travel through, and the conditions above frozen permafrost in deep winter conspire to strip away nearly every source and every enhancer of sound simultaneously. The ground is frozen and does not carry vibration easily. The air is cold and dense and does not carry sound as efficiently as warm air. There is little wind in the deepest cold, because temperature differentials that drive wind are reduced when everything is uniformly frigid. There are no insects. There are few birds. The snow, when it is present, absorbs what little sound is produced, softening and dampening every vibration before it can travel far. People who have spent time in the deep Arctic interior in winter describe the silence as having a physical quality, a presence, something that presses gently against the ears in the way that true silence does, when you encounter it so completely that the absence of sound becomes, paradoxically, a sensation. It is the sound of the permafrost world in its most natural state, a silence that has existed, in some form, since before there were ears to hear it. And it is still there, right now, in the deep north, vast and soft and cold, pressing gently against the winter dark. Silence, at its deepest, is not an absence. It is a presence that has learned to be very still. The richest permafrost deposits have a name that carries within it something of their extraordinary quality. Yadoma, a Russian word used by scientists to describe a particular type of permafrost deposit found across Siberia and parts of Alaska and Canada, formed during the Pleistocene from wind-blown sediment that accumulated rapidly, trapping enormous quantities of organic material before it could decompose. Yadoma is not ordinary frozen ground. It is frozen, almost soil, so dense in ancient organic carbon that its dark color and rich texture make it look, when thawed, like the most fertile compost imaginable. In some deposits, the organic content is so high that the material smells powerfully of life, even as it emerges from thousands of years of cold. Scientists describe Yadoma cores with an almost reverent attention to their texture and color, the way a sommelier might describe a wine, because each layer is genuinely distinct, carrying the signature of a different season, a different climate moment, a different assemblage of organisms from a world that no longer exists. It is frozen abundance. It is the compressed biological wealth of the Pleistocene steppe, the most productive grassland ecosystem that has ever existed on the planet's northern latitudes, held in suspension beneath the tundra, centuries deep. The most fertile places are not always where the growing is happening. Sometimes they are where everything is held in reserve. When permafrost meets the sea, what happens next is among the most quietly dramatic processes in the natural world. At coastal permafrost cliffs, where the frozen ground reaches the edge of the ocean and the waves arrive with their warmth and their mechanical energy, entire sections of ancient frozen land can collapse into the water in a single tidal cycle. Ground that held its shape for tens of thousands of years, that outlasted ice ages and interglacials and every human civilization, returns to the sea in a single night, the permafrost that held it together suddenly failing as the temperature of the water and the force of the waves combine to undo what the cold of millennia had maintained. Scientists who study these coastlines measure their retreat in meters per year in some locations, numbers that would have been inconceivable for most of the history of those shores. And what falls into the sea is not just sediment. It is the full permafrost archive, the ancient organic material, the preserved biological remains, the carbon held in cold for thousands of years, all of it released at once into the ocean, where it begins, finally, to decompose, to dissolve, to rejoin the cycles that the freezing had interrupted. The cliffs fall quietly, mostly at night, mostly unwitnessed. The sea receives what the cold had held, and the account, in a sense, closes. What is kept is not kept forever. The keeping itself is the gift, for however long it lasts. Ancient pollen, frozen inside permafrost, holds the memory of a garden that no living person has ever seen. Pollen is extraordinarily durable. Its outer wall, made of a material called sporopollenin, resists decay with a persistence that almost nothing in biology matches, surviving conditions that destroy virtually every other biological structure. And inside permafrost, where even fragile things are preserved, pollen survives in abundance, accumulating in layers that correspond to the seasons when particular plants were flowering across the Pleistocene tundra. Palynologists, scientists who study ancient pollen, can read these layers the way a musician reads a score. Each species a different note, the abundance of each type indicating how widespread that plant was across the landscape in a given era. From permafrost pollen records, they have reconstructed the composition of the mammoth steppe flora in remarkable detail. The grasses, the sedges, the wildflowers, the particular mix of plants that sustained the great herds of the Ice Age, all of it present in microscopic form, frozen in the dark, readable by those who know the language of ancient grains. A garden existed, vast and cold and full of life, and its pollen is still here, still identifiable, still telling anyone who asks what it was like to bloom 10,000 years before the first city was built. The flowers are gone, their pollen remains. The record outlasts the beauty that made it. The permafrost beneath your feet, if you stood above it, responds to what is happening on the surface with a delay measured not in hours or days, but in decades. Heat moves through frozen ground slowly, far more slowly than it moves through air or water, slowly enough that the temperature at depth responds to surface conditions on a timescale that makes the relationship between cause and effect almost impossible to perceive without instruments and patience. The deep permafrost in many regions is still responding, right now, to temperature changes that occurred before you were born. The ground beneath the tundra is adjusting to a past that is, in human terms, already history, catching up to conditions that the surface has already moved beyond. Scientists use this property deliberately, drilling boreholes and reading the temperature profiles within them, like a thermometer with a memory, extracting from the gradients in the frozen column a record of past surface temperatures going back centuries. The ground, in this sense, is a slow diary. It writes down what happens above it, one careful thermal entry at a time, and it holds those entries for decades before they reach the depth where instruments can read them. Even as you rest right now, the ground in the north is writing down tonight, in heat, in the language of slow conduction, for someone to read in 50 years. The earth keeps accounts in a ledger that takes decades to fill a single page. Inside the permafrost, a crowd of the deep past rests together, without distinction or order. Cave-bare skulls lie beside the bones of horses. The roots of ancient grasses are pressed against the remains of insects. Mammoth dung, still chemically analyzable, sits in the same frozen layer as the seeds of flowers that were growing when that dung was fresh. Bison ribs rest near the burrow of an ancient squirrel. Everything that fell onto the Pleistocene tundra and was preserved rather than fully decomposed is there together, a vast, still, frozen community of organisms from across tens of thousands of years of ecological time, all of them resting in the same cold darkness without any of the usual boundaries that separate one era from another. It is the most democratic archive imaginable. Nothing is curated. Nothing is arranged. The permafrost kept what the cold reached before decomposition could, without preference, without selection, without any principle of organization, beyond the simple fact of cold arriving in time. And so the cave bear and the bison and the ancient squirrel and the grass and the beetle are all there together, resting side by side across thousands of years, held in the same frozen dark, equally kept, equally cold, equally still. The past does not sort itself. It simply accumulates, layer by layer, in whatever order it arrived. The highest mountains near the equator hold a secret that most people never think to look for. Permafrost is not only a phenomenon of the far north, of tundra and Arctic coastline and Siberian taiga. It exists, quietly and without announcement, in the high Andes of South America, on the peaks of East Africa, in the mountains of Central Asia, far south of any latitude associated with permanent cold. What latitude cannot provide, altitude supplies. The temperature drops with elevation the way it drops with proximity to the poles, and above a certain height, the ground stays cold enough, continuously enough, to qualify as permafrost by the only definition that matters: 2 consecutive years below freezing. The mountain does not care how close it is to the equator. The cold does not negotiate with geography. And so there are places in the Andes where the ground beneath the high grasslands has been frozen quietly and continuously for thousands of years, just as it has in Siberia, just as it has in Alaska, simply because the altitude creates the same condition that latitude creates elsewhere. The permafrost world is larger than its maps suggest. It reaches into places where you would not expect to find it, tucked under high mountain meadows, sealed beneath the roots of grasses that grow under a tropical sun, while their roots extend into ground that has not thawed since long before those mountains had their current names. Cold finds its own way to wherever the conditions allow it to stay. The thaw of permafrost releases something that most people would not think to name among the things it holds: mercury. Ancient, heavy, primordial mercury, deposited across the northern hemisphere by volcanic eruptions that occurred before the last ice age and sealed into the permafrost as it formed around the volcanic fallout, layer by layer, across thousands of years of accumulation. The permafrost of the northern hemisphere contains an estimated quantity of mercury roughly twice the amount found in all other soils, the ocean and the atmosphere combined. It arrived there over geological time, settling out of the air and into the accumulating organic layers that the cold then sealed and held. It has been there, inert and frozen and harmless in its frozen state, since before any human civilization existed. Scientists discovered its presence through careful chemical analysis of permafrost cores, and the discovery required a recalibration of estimates about the global mercury cycle, because no one had previously accounted for a reservoir of this size, hidden in the frozen ground, waiting in a form that becomes mobile only when the temperature changes. The permafrost did not choose to hold it. The cold simply sealed everything it reached, without discrimination, keeping the ancient mercury alongside the ancient pollen and the ancient carbon and the ancient bones, all of it together, all of it still. The earth keeps what falls into it, without asking whether it was meant to stay. The scientists who work with permafrost cores operate in a particular kind of silence that has its own quality. The samples must be kept cold. Any warming, even slight, even brief, begins to change the biological and chemical record within them, initiating processes that have been paused for thousands of years and cannot be repaused once started. And so the laboratories where permafrost cores are analyzed maintain temperatures well below freezing, and the scientists who work in them do so in cold weather gear, handling samples with the care appropriate to objects that are genuinely irreplaceable in the most literal sense of the word. There are no duplicates. There is no backup archive. What is in a given core from a given location at a given depth is what exists, and if it is damaged or lost or allowed to warm beyond recovery, that particular record is gone. The scientists are aware of this in a way that gives their work a particular quality of attention. They move carefully. They speak quietly. They make decisions slowly. Colleagues describe a particular atmosphere in permafrost core laboratories, a seriousness that is not grim, but is very present. The seriousness of people who understand that they are the temporary custodians of something that does not belong to them, something that belongs, in some sense, to all of the time that made it. The most careful attention is given to things that cannot be replaced if the attention fails. The landscape above permafrost wears its frozen interior on its surface in ways that reward a second look. The flatness of the tundra, which can seem featureless to an unaccustomed eye, is the direct expression of the frozen layer below. In ordinary soil, water drains downward freely, carried by gravity through permeable ground to aquifers and rivers deep below. Above permafrost, that drainage is blocked. The water cannot penetrate the frozen layer, and so it spreads sideways, pooling in every low point, saturating the active layer above the permafrost, and creating the particular wet, spongy, level quality of tundra that makes walking across it feel so different from walking across any other landscape. The geometry of the surface, the particular distribution of wet areas and dry areas, of elevated ground and low ground, of polygon rims and polygon centers, is entirely determined by what is happening in the frozen layer below, by where the ice wedges run, by where the permafrost is deepest and where it is thinnest, by the slow, underground architecture of a landscape that expresses itself on the surface only indirectly, only through what it prevents, only through the water it refuses to let pass. The tundra looks the way it looks because of what is frozen beneath it. The visible world, here, is the shadow of the invisible one. What shapes the surface is almost always something you cannot see from the surface. Beneath some Siberian lakes, the floor never warms above freezing even in summer. This is not obvious from above. The lake surface catches the summer sun. The upper water column warms to temperatures comfortable for the insects and birds that gather at the shoreline in the brief Arctic summer. A swimmer, theoretically, could manage the upper layers, but below a certain depth, the lake floor rests on permafrost so thick and so cold that even the warmest summer, even the most persistent sunshine, cannot deliver enough heat through the water column above to raise the temperature of the sediment below freezing. And so the lake exists in two worlds simultaneously. A warm, living, seasonally active upper world of water and light and biology, and a cold, still, ancient lower world of frozen sediment and preserved organic material, separated by a thermal boundary that the sun can approach but never fully cross. Scientists study the sediments of these lake floors as they study permafrost cores, finding in the frozen material at the bottom the same layered record of past climates and past ecologies that the terrestrial permafrost holds. The lake is not just a lake. It is an archive with water on top of it. The water lives in the present. The floor lives in the past. Both exist at the same time, in the same place, separated only by depth and cold. The present and the past can occupy the same water, separated only by how far down you look. The permafrost holds elements that the living world needs, in quantities that have been locked away from use for thousands of years. Nitrogen, phosphorus, carbon in forms that become biologically available when released. These are the building blocks of growth, the materials that plants and microbes and animals require to build themselves. And the permafrost has been sequestering them since the Pleistocene, removing them from circulation in the active ecosystem and holding them in the frozen dark below the reach of roots and rain. When permafrost thaws, these elements are released, suddenly available after millennia of absence, and the ecosystems above them respond in ways that scientists are still working to understand and predict. Some areas see surges of plant growth as the newly available nutrients enrich the soil. Others experience shifts in microbial communities that change the chemistry of the active layer in unexpected ways. The release is not a simple addition. It is a disruption of balances that have been established over thousands of years without those nutrients in play. An ecological renegotiation that involves every organism in the landscape, from the smallest soil bacterium to the largest tree, all of them adjusting, slowly, to a changed chemistry that the frozen ground is only now releasing back into their reach. What is withheld long enough changes everything when it is finally returned. The microbes of the deepest permafrost have developed a capability that researchers find quietly extraordinary. They repair their own DNA. Not quickly. Not in the way your cells repair DNA, which is a rapid, energetically intensive process conducted by specialized molecular machinery, running continuously throughout your waking and sleeping life. In permafrost microbes, the same fundamental process occurs at a rate so slow it is almost geological, base pair by base pair, across timescales that dwarf the entire span of human history. Over thousands of years in the frozen dark, radiation from the soil itself, from the natural decay of trace radioactive elements in the mineral matrix, accumulates damage in the DNA of these organisms, breaking chemical bonds and disrupting the genetic sequences that define what the organism is and how it functions. And slowly, in the cold, with the minimal energy available to a metabolism barely running, these microbes repair that damage. They find the breaks. They restore the sequences. They maintain their biological identity across geological time through a process of continuous, glacially slow self-correction that has no equivalent in any surface organism. Scientists who study this process describe it with a particular kind of wonder, the kind reserved for things that are both alien and deeply familiar, recognizably biological, but operating on a timescale that the mind can describe but not quite feel. To repair yourself slowly, in the dark, across thousands of years, is a form of persistence with no common name. A glacier and a patch of permafrost can exist within sight of each other, but they are entirely different things. This distinction matters not just scientifically, but as a way of understanding what permafrost actually is, what makes it particular, what gives it its quality of stillness that a glacier, for all its cold, does not have. A glacier moves. It flows downhill under the influence of gravity and its own accumulated mass, grinding the rock beneath it, carrying debris, reshaping the landscape it passes through over centuries and millennia. It is dynamic cold. It is cold with direction and momentum. Permafrost does not move. It is not a flowing body. It is the ground itself, frozen in place, holding whatever is within it exactly where it is, not traveling anywhere, not driven by gravity in the way ice on a slope is driven. Where glaciers meet permafrost, there is a boundary between two kinds of cold, one that moves and one that holds, and the scientists who study that boundary describe it as one of the more conceptually interesting places in the cryosphere. The moving ice and the still ground press against each other across geological time, each following its own logic, each maintaining its own particular relationship to cold and to place. The glacier passes. The permafrost remains where it has always been. Some things move through the world. Others hold their place while the world moves around them. In permafrost regions, some instruments and signals behave in ways that require recalibration. Radio signals transmitted across permafrost landscapes travel differently than they do across ordinary ground. Compasses can behave unexpectedly in some permafrost regions due to variations in the magnetic properties of the frozen soil and the ice structures within it. Certain satellite positioning systems show anomalies over areas of deep permafrost, that require correction factors not needed elsewhere. The frozen ground changes how electromagnetic energy moves through and reflects from the landscape, and engineers working on infrastructure in permafrost regions must account for these effects in ways that have no equivalent in the temperate world. Ground-penetrating radar, which is used to map the depth and structure of permafrost from the surface, sends its signals into the frozen layer and reads what comes back, but the interpretation of those returns requires an understanding of how ice and frozen sediment interact with electromagnetic waves that took decades of fieldwork to develop. The permafrost is not passive. It interacts with the physics of the world above it in ways that are subtle, continuous, and consequential for anything that depends on precise measurement or reliable signal transmission across its surface. Even the invisible communications of the modern world must make accommodations for the ancient cold below. The oldest things still shape how the newest signals travel. The oldest biological material reliably dated from anywhere on Earth came from permafrost. Not from a peat bog, not from amber, not from volcanic ash or desert desiccation or any of the other environments that preserve organic material across geological time. From permafrost. Plant remains and insect fragments recovered from permafrost deposits in the Arctic and dated by multiple independent methods to ages exceeding 1 million years, still structurally recognizable under a microscope, still yielding enough chemical information for analysis, still present in the physical world, rather than converted entirely to mineral or trace. 1 million years. The span of time between those organisms and the world you inhabit tonight is so large that the entire history of anatomically modern humans fits inside it more than a dozen times, and yet the material is still there, still intact, still holding the shape and chemistry of living things that existed before our lineage had taken the form it now has. The permafrost held them through ice ages and warm periods, through the rise and fall of entire ecosystems, through everything that has happened on the surface above them, simply by being cold enough, continuously enough, to prevent the processes that would have erased them. 1 million years of keeping, without intention, without effort, simply by being cold. Something ancient is exhaling, not metaphorically, not as a figure of speech borrowed for effect. In the most literal biological sense, the microbes that wake as permafrost thaws, resume their metabolisms, consume the ancient organic material that the cold has held in reserve for them across thousands of years, and breathe out carbon dioxide, methane, the actual gaseous exhalation of organisms resuming a process that was interrupted by the arrival of the cold during the Pleistocene, now picking up exactly where they left off, releasing into the atmosphere the carbon that was sealed into the frozen ground when the mammoths still walked above it. Scientists measure this release with instruments placed directly on the tundra surface, small chambers that capture what the ground exhales across a given area, across a given period of time, and the numbers they return are carefully, precisely noted, because what they are measuring is not a small thing. The permafrost carbon feedback, as it is formally known, is one of the most consequential processes currently underway in the Earth system. The ancient microbes do not know this. They are simply doing what microbes do. They are eating. They are breathing. They are, in their way, simply continuing. The carbon they release was alive once in the bodies of Pleistocene plants and animals, and now it is alive again, briefly, in the metabolisms of organisms waking after an ice age sleep before it rises into the air and joins the present. What was kept is being spent, slowly, breath by ancient breath. The people who have known the frozen ground longest carry knowledge that no instrument has yet fully replicated. Across the Arctic and subarctic world, from the Nenets of Siberia to the Inuit of Canada to the Sami of Scandinavia, generations of direct, consequential relationship with permafrost terrain produced an understanding of the ground that is simultaneously practical and profound. Which slopes are safe in which seasons? which sounds the Earth makes as conditions change, which plants grow above stable permafrost, and which appear where the ground is beginning to shift, which roots hold through winter, and which soften unpredictably in spring. This knowledge was not academic. It was survival knowledge, developed through generations of living directly with the consequences of understanding or misunderstanding what the ground was doing. Scientists working in permafrost regions have increasingly come to recognize that this accumulated observational record, spanning centuries in some cases, represents a longitudinal dataset of landscape behavior that no instrument network established in the last few decades can match for depth or continuity. The collaboration between traditional ecological knowledge and modern permafrost science is still in its early stages, still learning how to ask and answer questions across very different systems of understanding. But the frozen ground has been known, in its own way, for a very long time, by people who could not afford to be wrong about it. The oldest knowledge is not always written. Sometimes it is simply lived, carefully, for a very long time. There is a smell that belongs to no living world. Those who work near thawing permafrost describe it consistently. Rich, dark, dense, a scent with no modern equivalent, because the material producing it has not been exposed to open air since before any modern ecosystem existed. Ancient organic carbon, sealed from oxygen since the Pleistocene, meets the present atmosphere as the frozen ground opens, and the chemistry of that meeting produces a smell that researchers find difficult to describe, precisely because there is nothing in ordinary experience to compare it to. It is not the smell of soil, exactly, though it contains something of that. It is not the smell of decay in the familiar sense, though decomposition is part of what is happening. It is something older and denser than either, the smell of biological material that accumulated during an era when the planet's ecosystems were organized entirely differently, when different animals grazed the land, and different plants covered it, and different microbes processed the organic matter that fell into the accumulating frozen layers. Scientists who have encountered it speak of it as the most visceral reminder of where they are and what they are working with, more immediate than any instrument reading, more present than any data point. The past, in that moment, is not a concept. It is in the air. It is inside them. They are breathing the Pleistocene. Some knowledge arrives not through the mind but through the oldest sense we have. Beneath the Tibetan Plateau, where the ground has been frozen for at least 130,000 years, something waited that science had not yet named. Researchers drilling into the permafrost of the Gulia ice cap in Tibet recovered ice cores containing genetic material from viruses belonging to families so ancient and so distinct from anything in current databases that they could not be classified within existing taxonomic frameworks. Not merely old versions of known viruses, genuinely novel lineages representing branches of viral evolution that diverged from known families so long ago that the divergence itself predates the geological record in which the ice that preserved them formed. The scientists who analyzed these cores were careful, precise, and appropriately measured in their descriptions of the findings. The viruses pose no identified threat to human health. They are, as far as can be determined, adapted to the single-celled organisms of the ancient ice environment, following appetites evolved for a world very different from the present one. But their presence in the ice raises questions that are genuinely open, genuinely interesting, about the history of viral life on Earth, about how many lineages exist in the frozen archive that science has not yet encountered, about what else the permafrost and ancient ice are holding that has not yet been found, because not enough of it has yet been looked at carefully enough. The catalogue of life on Earth is not finished. The frozen ground still holds entries that have not yet been read. Above the permafrost in summer, the tundra becomes a mirror stretched across the horizon. the shallow, active layer, saturated with water that cannot drain through the frozen ground below, becomes a reflective surface in the slanted Arctic summer light, pooling in every depression and spreading across every flat expanse, until the landscape is as much water as land, or more. Thousands of small ponds and wet channels and saturated meadows reflect the enormous Arctic sky back at itself, creating a doubled world in which the clouds move both above and below the horizon simultaneously, in which the light comes from two directions at once, in which the boundary between earth and sky becomes genuinely ambiguous. Migratory birds arrive at this flooded landscape in their millions, drawn by the sudden abundance of insects that emerge from the thawed active layer and the aquatic invertebrates that colonize the shallow ponds. The tundra, which in winter is among the most austere landscapes on Earth, becomes in summer one of the most productive, supporting an explosion of life so concentrated and so brief that it has the quality of something dreamed rather than something real. And all of it, the birds, the insects, the shallow ponds, the reflected sky, exists because of what is frozen below. The permafrost creates the mirror. The mirror creates the world that forms above it. What is frozen below determines what can live above. The cold is not the absence of life. It is its condition. Inside the permafrost, ice wedges have been growing since before the oldest living tree was a seed. These vertical sheets of ice, which form in the cracks that cold opens in the frozen ground each winter, accumulate one thin layer at a time, each winter adding a fraction of a millimeter to a structure that has been growing continuously for up to 10,000 years. The oldest ice wedges are not dramatic objects. They do not announce their age. They appear in the walls of permafrost exposures as pale vertical bands in the darker frozen soil, widening toward the surface where the most winters have contributed their layers, narrowing downward into the original crack where the process began. Scientists can read their age from their width, roughly, and from the isotopic composition of the ice within them, which records the temperature of the winters that formed each layer with a fidelity that makes them, in effect, a 10,000-year record of Arctic winter temperatures written in ice, one winter at a time. 10,000 years of winters, 10,000 cold seasons, each one adding its contribution to a structure that no one was watching form, in a darkness that no light has ever reached, in a silence broken only, perhaps, by the faint creak of the ground contracting in the deep cold, opening the crack a fraction wider, allowing the next layer of water to enter and freeze and become part of what was already there. Patience, practiced in the dark for long enough, becomes a monument. The carbon inside permafrost was not always carbon dioxide or methane. It was once alive. This is the fact that changes the texture of the whole subject. If you let it settle, the carbon held in frozen suspension beneath the tundra is not geological carbon, in the sense of carbon that has been mineral for millions of years, never part of anything breathing. It is biological carbon. It is the compressed, frozen remnant of actual organisms, grasses that bent in the Pleistocene wind, roots that drew water from the Pleistocene soil, insects that flew through the Pleistocene summer air, animals that grazed the Pleistocene steppe and left their biological material to the ground when they died. All of that life, all of those specific organisms with their specific biochemistries and their specific ecological relationships, became part of the frozen record when the cold arrived quickly enough to seal them before they could fully decompose. The carbon in the permafrost is not abstract. It is the specific carbon of specific ancient lives, held in the form of frozen organic matter, waiting in the dark. When it is released, it rejoins the atmosphere not as something new but as something returned. Carbon that was last in the air during the Pleistocene, cycling through the world again after tens of thousands of years of cold storage. beginning again the journey it was on when the cold interrupted it. The past is not inert, it is stored, and stored things, eventually, re-enter the present. The researchers who spend months in permafrost field stations describe a particular relationship with time. Not the speeding up that busy modern life produces, not the compression of days into sequences of tasks and responses and obligations. Something closer to the opposite. In the slow, cold, vast landscapes of the permafrost world, surrounded by ground that measures time in millennia, working with material that predates every human institution, the ordinary markers of temporal urgency simply fail to apply in the usual way. Scientists who have spent extended periods at remote permafrost research stations, particularly those that operate through the polar winter, describe a quality to time there that is difficult to convey to anyone who has not experienced it. Slow, recursive, circular, without the clear edges that punctuate time in more connected environments. Days resemble each other. The landscape does not change visibly from one week to the next. The work is slow by necessity, careful, repetitive in the way that all good scientific observation is repetitive, and the ground they are working in was already ancient when the concept of a research station was invented. Something of that ancientness, researchers say, enters the experience of being there, not oppressively, not overwhelmingly, gently. The permafrost does not hurry, and after a while, without quite deciding to, neither do the people working with it. To spend time with something ancient is to borrow, briefly, its relationship with time. The permafrost does not distribute itself evenly. It follows its own logic, visible only to those who learn its language. A single hillside in a permafrost region can shift from deeply frozen to entirely unfrozen ground within a few horizontal meters. The boundary determined not by any grand geographical feature, but by the accumulated influence of small variables. The angle of the slope relative to the sun, the depth of the winter snow cover, the particular vegetation that grows there, and how effectively it insulates the ground below, the presence or absence of a single large rock that shades the ground beside it across summer afternoons. Each of these factors, alone, is modest. Together, their combined effect can be the difference between ground that has been frozen for 10,000 years and ground that has never frozen at all, lying side by side on the same hillside, beneath the same sky, under the same sun. Scientists call these sharp boundaries between frozen and unfrozen ground permafrost edges, and they are among the most biologically interesting locations in permafrost landscapes, places where the ecological consequences of the frozen ground are most visible, where the contrast between the world the permafrost creates and the world that exists without it can be seen directly in the vegetation, in the soil moisture, in the particular assemblage of organisms that each condition supports. The world draws its most interesting lines not on maps, but in the invisible boundaries between conditions. In the heart of ice, permafrost records the direction of ancient storms. Within the ice crystals that form in permafrost, the orientation of the crystal lattice, the precise geometric arrangement of the water molecules frozen in place at the moment of crystallization, preserves information about the conditions under which the freezing occurred, the direction from which the cold front arrived, the speed of temperature drop, the particular atmospheric conditions of a specific winter that has not existed for thousands of years. Scientists using specialized instruments can read these orientations and reconstruct, with varying degrees of precision, something of the meteorological history encoded in the crystal structure, a compass made of frozen water, pointing towards storms that came and went before any human was present to observe them. It is a form of record so specific and so physical that it operates entirely outside the realm of anything that could be described as testimony or memory in any human sense. It is simply physics, preserving information in structure, the way physics always does, without intention, without selection, without any awareness that a record is being kept. And yet the record is there, readable, real, pointing in directions that correspond to weather systems that crossed a landscape 10,000 years ago and have not been thought of by anything capable of thought since the moment they passed. The world keeps records it does not know it is keeping, in structures too small to see with unaided eyes. The bacteria of the deep permafrost have been doing something that researchers find quietly revolutionary. Not surviving, that word is too passive for what has been observed. These organisms, sealed in frozen ground for tens of thousands of years, have been producing antifreeze proteins, molecules that bind to forming ice crystals and physically prevent them from growing large enough to puncture cell membranes from the inside. Not a passive tolerance of cold, an active, biochemical response to it, a molecular technology evolved specifically for an environment that has been frozen since before our species existed, refined across geological time, in the dark, in the cold, in the absence of any observer to note the refinement taking place. These proteins work by a mechanism so elegant that material scientists have studied them as models for synthetic antifreeze compounds, looking to biology for solutions to engineering problems that human ingenuity has struggled to solve. The permafrost microbes arrived at those solutions not through design but through the slow pressure of an environment that eliminated every organism that could not manage it, across millions of generations conducted in temperatures that would stop most life entirely. What remains, what has persisted into the present, is life that has been exquisitely, specifically, patiently shaped by cold, into something that cold cannot easily defeat. The oldest lessons are sometimes the ones that took the longest to teach, in classrooms made of ice. There is a substance at the boundary of deep permafrost and ocean floor that burns while still holding the structure of ice. Methane hydrates. The name is precise, and the reality is stranger than the name suggests. At the specific combinations of pressure and temperature found at the lower boundary of thick permafrost and at certain ocean floor depths, methane, gas and water molecules combine into a lattice structure, a cage of frozen water enclosing molecules of methane, solid at temperatures above the normal freezing point of water because the pressure holds the structure together. The result is a substance that looks exactly like ordinary ice, feels cold and solid in the hand, and yet, if exposed to flame, burns because the methane released as the ice structure destabilizes is combustible. Scientists who demonstrate this for the first time to observers describe a consistent reaction, a moment of complete cognitive disorientation, because the image of burning ice violates something so fundamental about the categories of cold and heat, solid and gas, that the mind requires a moment to simply accept what the eyes are showing it. Vast quantities of methane hydrate exist at the permafrost ocean boundary in the Arctic, holding an enormous amount of carbon in a form that is stable only within a narrow range of temperature and pressure, a stability that the changing ocean is beginning, very slowly and at its edges, to test. Some things are held together not by strength, but by the precise maintenance of particular conditions. The word that named the phenomenon arrived late, long after the thing itself had been quietly present for millennia. Permafrost entered the scientific vocabulary in 1943, coined by the American geologist Simon Muller as a practical shorthand for what earlier researchers had called variously frozen ground, perennially frozen ground, and several other descriptive phrases that had not achieved universal adoption. The Soviet scientific tradition had its own terminology, developed through decades of engineering work in Siberia, where building on frozen ground was a practical necessity rather than an academic curiosity. But the English word permafrost, short and clear and carrying its meaning within itself, was adopted broadly and persisted. What strikes researchers who think about this history is the lateness of the naming relative to the age of the thing being named. The permafrost had been frozen for tens of thousands of years before any human walked above it. It had been frozen for the entirety of human prehistory and history, before the first systematic scientific study of it began. It had been frozen through every era that produced every word in every language, before anyone felt the need to give it a single, stable name. Named late, known intimately by the people who lived above it, long before the name arrived. Present, patient, and unnamed, for almost all of the time it has existed. The oldest things are often the last to be formally introduced. The permafrost holds the shapes of worlds that no longer exist on any surface. Ancient riverbeds, long since dry, their courses pressed into the frozen ground by the weight and chemistry of water that stopped flowing thousands of years ago. Ancient shorelines, preserved in the sediment layers of permafrost deposits, marking the edges of lakes and seas that have since retreated, expanded, or disappeared entirely. The preserved record of storm events, of flood deposits, of drought layers, of every significant meteorological event that left a mark in the accumulating sediment before the cold sealed it in place. Scientists call this the paleotopographic record, and they read it with the same care and the same awareness of irreplaceability that applies to every aspect of permafrost research. What is preserved in the frozen ground is not just biology, it is geography, the shapes of a world that no longer has those shapes, held in cold suspension beneath a landscape that looks entirely different now, available to anyone willing to drill carefully enough and read the frozen layers with the attention they require. The permafrost is not just an archive of what lived, it is an archive of where things were, and what the land looked like, and how the water moved, across every era it has preserved. Beneath every present landscape, the frozen memory of every previous one waits in the dark. For centuries, the people of Alaska have carved their freezers directly into the earth. Not metaphorically, not as a cultural practice that resembles modern refrigeration in some loose analogical sense. Literally, communities across Alaska and other permafrost regions have, for generations, excavated cellars into the frozen ground and used the stable, consistent cold of the permafrost itself to preserve food across seasons: meat, fish, marine mammal products that require sustained cold to remain safe across the months of the year when hunting and gathering are not possible. The permafrost provided, without any energy input, without any technology beyond the tools needed to dig into it, a cold storage environment more reliable and more consistent than anything engineered refrigeration achieves without continuous power. These ice cellars, as they are called, are still in use in many Alaskan communities today, still fulfilling the same function they have fulfilled for hundreds of years, still relying on the same frozen ground that has been providing that cold since long before the communities above it existed. The relationship between the people and the permafrost is not abstract. It is practical, daily, rooted in a direct physical engagement with what the frozen ground offers, used with the matter-of-fact ease of people who have known something intimately for a very long time. The most reliable technologies are sometimes the ones that were always just there, waiting to be understood. Even now, in ground frozen for 40,000 years, the thinnest possible version of liquid water persists. This is the fact that those who study permafrost return to most often when asked to identify the single detail that most reframes their understanding of what the frozen world actually is. The assumption that frozen means entirely frozen, that below zero means the complete absence of liquid water, turns out to be incorrect at the scale of individual soil particles. In the microscopic films that form between ice and mineral surfaces, the chemistry of the interface prevents complete freezing, maintaining a layer of water so thin that it is measured in nanometers, a thickness so small that placing 500 of these films side by side would not span the width of a single human hair. In this almost water, in this film that is not quite liquid and not quite ice, some bacteria can move, some chemical reactions can proceed, some of the most minimal biological processes can occur. The frozen ground is not entirely still. It is mostly still, profoundly still, still in a way that exceeds any ordinary definition of stillness. But at its very margins, at the boundary between what is frozen and what resists freezing, something is always, barely, gently, continuing. Even as you rest right now, in permafrost frozen since the Pleistocene, in the width of a nanometer-thin film of almost water, life has not entirely stopped. The space between frozen and not frozen is smaller than anything you can see, and yet something has always lived there. A woolly mammoth tusk, recovered from permafrost, carries within it the autobiography of its owner. Not metaphorically. The chemical composition of mammoth ivory changes as the animal grows, incorporating the isotopic signatures of whatever the mammoth was eating and drinking at each stage of its life, season by season, year by year, recording in its molecular structure the geography of the animal's movements, the quality of the seasons it experienced, the periods of abundance, and the periods of hardship that left their marks in the chemistry of the growing tusk. Scientists who analyze these isotopic profiles can reconstruct, with remarkable precision, the biography of an individual animal, where it was born, where it moved across its lifetime, which seasons were good and which were difficult, at what age it died, and under what nutritional circumstances. The permafrost preserved not just the physical object of the tusk, but the chemical information encoded within it, the autobiography of a life lived tens of thousands of years ago, written in isotopes in the ivory, and held there perfectly, by the cold, until someone came with the instruments to read it. One animal, one lifetime, one tusk, an entire personal history, kept in the frozen ground, waiting to be understood. Every life leaves a record in its own body, whether or not anyone is there to read it. The tundra above permafrost, viewed from high above, shows patterns of water that form nowhere else on Earth. Beaded drainage. The name describes it with unusual accuracy. Strings of small, roughly circular ponds connected to one another by narrow channels, arranged across the landscape like beads on a thread, repeating in every direction as far as the aerial view extends. This pattern forms only where permafrost controls the movement of water absolutely, preventing it from draining downward, forcing it to pool in every small depression, and then connect those pools through the shallowest available channels along the surface. The ponds that form are not random. Their size and spacing reflect the underlying structure of the frozen ground, the locations of ice wedges and frost polygons, the subtle topography created by thousands of years of freeze and thaw acting on the surface above the permafrost. From a low-flying aircraft, or from satellite imagery, a permafrost landscape in summer is immediately distinguishable from any other kind of landscape on Earth by these patterns, these long strings of dark water threading through pale tundra, connecting pool to pool to pool across hundreds of kilometers of frozen ground. No designer drew these lines. No process other than cold and water and the particular way they interact in this particular landscape could have produced them. They are the permafrost writing itself, in water, on the surface of the world. The most complex patterns are often made by the simplest rules, applied patiently, for long enough. Within the permafrost, at every depth, something is not moving, not reacting, not changing, in a way that has no parallel in any surface environment. The stillness of deep permafrost is not the stillness of an empty room, which is still only because nothing is in it. It is the stillness of a room so full of things that nothing has room to move. Full of organic material, full of ice, full of mineral particles, full of ancient biological structures, full of chemical bonds frozen in mid-reaction, full of enzymes arrested mid-catalysis, full of cells that were dividing when the cold arrived, and are still, tens of thousands of years later, in the state they were in when the division stopped. A spore mid-germination, a crystal mid-formation, a chemical process mid-step, all of it frozen not into absence but into a kind of pause so complete and so prolonged that it becomes, at some point, indistinguishable from permanence, though it is not permanent, though it is always, in principle, reversible, though warmth could resume every one of these paused processes if it arrived with sufficient persistence. The permafrost is not a place where nothing is happening. It is a place where everything that was happening stopped, mid-motion, and has been waiting in exactly the position it stopped in ever since. A world caught in the act of being itself, held there by cold, for as long as the cold holds. The universe is full of things that are not gone, only paused, waiting for the right conditions to continue. The cave lion cubs of Siberia arrived from the permafrost with something that no fossil has ever offered. Their posture, the specific, particular, individual way each cub had arranged its body in the moment the cold took it, preserved so completely in the frozen ground that scientists could examine not only the biology of the specimens, but the behavioral evidence encoded in the position of their limbs, the angle of their heads, the relationship of their bodies to the space around them. This is information that fossilization never preserves. Stone remembers shape, not arrangement. Mineral replacement captures anatomy, not posture. But the permafrost, which does not replace or mineralize, which simply holds, returned these animals in the exact configuration they were in when they died, allowing researchers to observe, directly, how a cave lion cub positioned itself in its final moments, what shape a Pleistocene predator took at rest, how the body of an extinct species organized itself in the particular way that bodies organize themselves when they are no longer managing themselves. Scientists described examining the specimens with a quality of attention usually reserved for things that are still alive, because in some visual sense, the distinction was difficult to maintain. The cold had kept them so completely that only the absence of breath distinguished them from sleeping. What the cold keeps, it keeps whole. Not the idea of a thing, the thing itself. The bones of animals gone from the world for 10,000 years still carry something living inside them. Collagen, the structural protein that gives bone its flexibility and tensile strength, survives in permafrost-preserved specimens in quantities sufficient not only for identification, but for detailed molecular analysis, including the extraction and sequencing of ancient DNA. Mammoth bones recovered from frozen deposits have yielded collagen samples so intact that researchers were able to compare the protein sequences directly with those of living elephants, mapping the precise molecular distance between a species that vanished 10 millennia ago and its closest living relatives. Horse bones, bison bones, the bones of species that were alive during the last ice age and are now represented only by frozen remains and the faint genetic echo they left in living populations. The cold did not simply preserve the shape of these animals. It preserved the chemistry of their tissues, the molecular architecture of their biology, the specific proteins that held their bodies together across lifetimes, lived in a world we can now only partially reconstruct. When scientists extract DNA from these specimens, they are not reading a copy of the past. They are reading the past itself, the actual genetic sequences of actual individuals, preserved by the actual cold of the actual permafrost, returned from 10,000 years of frozen keeping, in a form still legible to the instruments of the present. The living world has a longer memory than it appears to, held in the frozen remnants of what it used to be. The scientists who excavate permafrost carry with them an awareness that has no equivalent in most other fields. They are the archive and the excavation simultaneously. The act of studying permafrost is also, unavoidably, the act of disturbing it. To drill a core is to introduce a borehole where the frozen record was continuous. To thaw a sample for analysis is to initiate the very processes that the cold had held in suspension, to begin the decomposition that the freezing had prevented, to read the record in a way that partially erases it as you read. There is no permafrost research that does not alter, in some small way, the thing it is studying. Scientists are deeply aware of this, and the awareness shapes how they work, slowly, carefully, extracting the minimum necessary, preserving every sample that is not immediately needed in conditions as close to the original as technology allows, treating each core and each specimen as what it genuinely is, something that cannot be made again, something that the world produced over tens of thousands of years and will not produce again regardless of how much time passes. This is not paralyzing. The scientists work, but they work with a particular quality of attention, a care that is not merely professional but something closer to ethical, an acknowledgement that what they are holding is not their own, and that their responsibility to it extends beyond the completion of any individual study. To study something irreplaceable is to accept a responsibility that outlasts the study itself. Above the permafrost, the thin, active layer wakes each spring with a particularity that rewards slow attention. The active layer, that shallow band of soil above the permafrost that freezes each winter and thaws each summer, is where all visible tundra life happens, where the roots of Arctic plants reach as deep as they can reach before hitting the frozen barrier below, where the insects emerge in their brief, intense summer abundance, where the migratory birds find the invertebrates they have flown thousands of kilometers to reach, where the surface waters pool and the sedges grow and the cotton grass bends in the Arctic wind. It is, in ecological terms, an extraordinarily productive environment for its brevity, compressing into a few summer weeks a biological intensity that many temperate ecosystems sustain across an entire year. And every autumn, it stops. The cold descends, the active layer freezes, and the tundra returns to the stillness of the permafrost world below, sealed again under snow, quiet again under polar darkness, resting again in a silence that will last until the following spring returns, and the thin layer wakes once more, and the whole brief, intense, extraordinary performance begins again. It has been doing this yearly waking and sleeping, above the continuously frozen ground below, for thousands of years, without interruption. The most productive lives are sometimes the ones lived in the narrowest windows, with complete attention. The ancient air inside permafrost ice tells a story that no other record on Earth can tell with the same directness. Bubbles of atmosphere, trapped in the ice of permafrost and glacier deposits, have allowed scientists to extend the chemical record of Earth's atmosphere back across hundreds of thousands of years, reading the concentrations of greenhouse gases in past eras with a precision that indirect methods cannot match, because the record is not inferred from proxies, but measured directly from preserved samples of the actual atmosphere. What those measurements show, when the most recent portion of the record is examined, is an increase in greenhouse gas concentrations over the past century that has no precedent in the entire preserved record going back 800,000 years. Not a change similar in magnitude to past changes, not a change at the faster end of a historical range, a change without parallel in the entire archive. The ice that preserved this record did so without any awareness of what it was preserving, without any intention to provide a baseline for comparison with future conditions. It was simply cold, and the air was simply trapped, and the record was simply kept for hundreds of thousands of years until the instruments and the questions arrived to make use of it. The frozen ground became, without knowing it, the most important piece of evidence in one of the most consequential scientific conversations in human history. The Earth kept the receipt. The question is, what we do now that we have read it. Inside a permafrost core, the passage of time has a color. Scientists who work with these cores describe a visual experience that is unlike anything else in their professional lives. Holding a cylinder of frozen earth, in which the column of time is literally present as a sequence of visible bands, each one a different color, corresponding to a different era, a different climate, a different biological community, compressed into a length that can be held in both arms. The ochre of oxidized sediment from a warm interglacial, the deep black of Yadoma, so rich in ancient organic material that it darkens the core like ink, the pale gray of glacial sediment, mineral-rich and biology-poor, deposited during the coldest periods when little was growing on the surface above, the warm brown of peat layers, compacted plant material from eras when the tundra was wetter and mosses accumulated in thick mats, the white of pure ice bands, lenses of ancient frozen water with no sediment at all. Each transition between colors is a transition between worlds, a boundary between one climate state and another, one ecosystem and another, one era of Earth history and another, all of it present simultaneously in a single object that someone is holding in a cold laboratory, reading with their eyes before any instrument is brought to bear, seeing time directly as color, compressed into something the arms can span. Time, when you hold enough of it at once, turns out to have a palette. The permafrost is changing, and the change, once begun, tends to encourage itself. This feedback dynamic, which scientists study with careful attention and describe with careful language, operates through a mechanism as simple as it is consequential. Permafrost, in its frozen state, reflects more solar energy than the wet, dark soil that replaces it when it thaws. It also releases carbon and methane when it thaws, gases that add to the warming that caused the thawing in the first place. And the landscape that forms as permafrost thaws, with its dark thermokarst ponds and its wet, exposed sediment, absorbs more heat than the tundra it replaces, warming the ground around it and accelerating the thaw at the margins. Each step in the process creates conditions that make the next step more likely, a self-reinforcing sequence that does not require any external push once it has begun, only the maintenance of the conditions that initiated it. Scientists study these dynamics not to generate alarm, but to understand the system accurately, because accurate understanding is the only foundation for any useful response. The permafrost is not fragile in the human sense of that word. It is vast and deep, and has outlasted everything, but it is sensitive, in the physical sense, to conditions it has not experienced for tens of thousands of years, and those conditions are arriving now, from above, from the atmosphere, slowly, persistently, for the first time since the Pleistocene ended. The most ancient things are not immune to what the present brings. They are simply slower to respond to it. The Arctic ground squirrel sleeps in the permafrost in a way that should not, technically, be possible. During hibernation, which it conducts in burrows dug into or near the permafrost layer, the Arctic ground squirrel allows its body temperature to drop to levels below the freezing point of water, the lowest body temperature recorded in any mammal during hibernation, and does so without the ice crystal formation in its tissues that would, at those temperatures, be lethal to any other mammal known to science. The mechanism by which it achieves this, supercooling its body fluids below freezing without allowing ice to nucleate within its cells, is still not entirely understood. Scientists have studied it with the focused attention appropriate to a phenomenon that combines physiological impossibility with observable fact. And while the broad outlines of the mechanism are increasingly clear, involving the careful management of ice nucleating particles in the blood and tissues, the precise details remain an area of active research. The squirrel, for its part, does this every winter, has been doing it for as long as its species has existed, and emerges each spring with complete physiological normality, warm and alert, and hungry, as though the winter were simply a long night that it had slept through without difficulty. It lives directly with the permafrost. It sleeps in its cold. It wakes from it without apparent consequence every year, the way the permafrost itself wakes the ancient microbes. Slowly, gently, completely. The cold is not always an ending. Sometimes it is simply a season, and the season always turns. The deep winter silence above permafrost has been described by those who have sat within it as a kind of presence, not an absence of sound in the ordinary sense. Something more active than that, more palpable, more difficult to dismiss as simply the lack of something. Researchers and indigenous community members who have spent time in the deep Arctic interior during the coldest months describe a quality to the silence that feels, paradoxically, inhabited, as though the silence itself has a texture, a weight, a directionality. Partly this is the physics. Sound behaves differently in very cold, very dense air over a very hard frozen surface, bending and absorbing in ways that make even small sounds strange and close, and then suddenly absent. Partly it is the contrast with the sound environments most humans inhabit, which contain so much continuous background noise that its complete removal is physically disorienting. And partly it may be something harder to explain, the particular quality of being in a landscape that has been this quiet, this consistently, for so long, that the silence feels earned rather than accidental. The permafrost has been cold and still and quiet beneath this sky for tens of thousands of years. The silence above it has, in some sense, been practicing for just as long. Even as you rest right now, that silence is continuing in the deep north, vast and patient and very, very still. Some silences are not empty. They are old, and old silences have a quality that new ones do not. The permafrost of the northern hemisphere holds more carbon than all the world's forests combined. This comparison is worth sitting with slowly, because forests are the thing most people think of first when they think of stored carbon, the great green lungs of the world, the vast living reservoirs that environmental conversations so often center on. And the forests are enormous. They are genuinely, importantly enormous. But the permafrost holds more, roughly twice the amount currently in Earth's atmosphere, as was said earlier. But more than all the forests, more than the Amazon, more than the boreal forest that circles the top of the world, more than every jungle and woodland and stand of trees that currently exists on the planet's surface, combined, held not as living wood but as frozen organic matter, compressed and cold and sealed from the oxygen that would allow it to decompose, accumulated over tens of thousands of years in the soils and sediments of the northern tundra and taiga. It arrived there slowly, invisibly, without any announcement, deposited one season at a time, as the organisms of the Pleistocene lived and died and were kept rather than decomposed. And it is there now, beneath the tundra, beneath your awareness, beneath the surface of a world that is mostly unaware of what the frozen ground is holding on its behalf. The largest storehouse is not the one in plain sight. It is the one that has been quietly doing its work underground. Every living thing that fell onto the Pleistocene tundra and was kept by the cold is still, in some sense, there. Not as a concept, not as a category, as individual organisms, specific and particular and real. The individual grass blades, the individual seeds, the individual insects, frozen in mid-flight or mid-feeding, their wings still spread in the position they held when the cold arrived quickly enough to take them before they could fold. The individual leaves from individual trees that no longer grow in those latitudes, falling from branches onto a tundra that looked different from any tundra that exists today, lying there for a season, being covered by the accumulating sediment, being sealed by the cold, becoming part of the record. Each of them is still there. Each specific organism, not a species representative, not a symbolic sample, but the actual individual that lived and fell and was kept, is still present in the frozen ground, in the form it had when the cold found it. The permafrost is not an archive of types, it is an archive of individuals, of specific lives, specifically kept in the specific forms they had when they entered the cold. It is the largest collection of specific individuals in Earth history, and almost none of them have ever been found, because almost none of the permafrost has ever been opened, and the archive vastly exceeds the reading that has been done of it. The frozen world holds more specific lives than all the named individuals in all of human history. The animals returned to us by permafrost sometimes arrived looking so recent that the people who found them were genuinely uncertain what they were seeing. Local hunters and herders in Siberia and the Yukon, encountering well-preserved permafrost specimens in eroding riverbanks or thawing hillsides, have on multiple occasions initially believed the remains to be of animals that had died recently, perhaps in the previous winter, perhaps earlier in the same season. The fur was present. The smell, while distinctive, was of something organic and recently exposed rather than ancient. The tissue, though frozen and stiff, had not acquired the mineral quality of fossils, had not flattened or compressed, had not lost its three-dimensional form. It looked like an animal. It looked, in the way that matters most to a person who has spent a lifetime recognizing animals, like something that had recently been alive. The cognitive adjustment required to accept the true age of these specimens, once radiocarbon dating and other methods were applied, was one that researchers and community members alike describe as genuinely disorienting, a recalibration of the intuitive sense of time that ordinary life calibrates around much shorter intervals. Not because the evidence is ambiguous. The evidence is clear, but the appearance is so immediate, so present, so lacking in the visual cues that the mind associates with great age, that the knowledge and the perception require a moment to align. Some things from the deep past arrive looking so much like the present that only careful measurement can tell them apart. The thaw of permafrost is not a single event happening in a single place at a single rate. It is a mosaic of processes, simultaneously occurring across thousands of kilometers of landscape, each patch following its own timeline determined by its own particular set of local conditions, its aspect and elevation and vegetation and snow cover and proximity to water, and the specific history of disturbance or protection that has shaped its relationship to cold over the centuries. In one location, the permafrost, near the surface, may have been stable for decades, and then begin thawing suddenly as a change in the vegetation above it reduces its insulation. In another location, permafrost that was expected to remain stable continues to do so because local conditions have, so far, buffered it against the broader warming trend. In a third, thaw proceeds from below, as well as above, driven by groundwater moving through a talc, the unfrozen zone that can develop within the permafrost layer when conditions allow liquid water to persist at depth. Scientists who study permafrost thaw speak of it not as a front advancing uniformly across a map, but as 1,000 simultaneous experiments in landscape physics, each one governed by its own variables, each one proceeding at its own rate, each one teaching something specific about how the frozen ground responds to the conditions arriving from above. The world does not change all at once. It changes everywhere differently, following the particular logic of each particular place. The smell of the deep past, when permafrost opens, enters the body before the mind can name it. This sequence matters. The nose is the oldest of the senses in evolutionary terms, connected to the brain through pathways that predate the structures responsible for language and conscious reasoning, capable of triggering recognition and response before any verbal processing has occurred. When researchers encounter the smell of thawing permafrost, the response arrives before the explanation. Something is recognized at a level below language, something that corresponds to no lived experience, because no living human has smelled this before. And yet the body responds as though it does correspond to something, as though the ancient chemistry arriving from the frozen ground activates something deep and pre-linguistic in the sensing organism above it. Scientists who describe this experience return repeatedly to the word primordial, not as a poetic choice, but as the most accurate word available for an encounter that feels genuinely prior to the ordinary categories of experience. The past is not usually accessible through the senses. History is typically mediated through text, through image, through the mineral record of fossils and sediments. The smell of thawing permafrost is different. It arrives directly, without mediation, without translation, in the oldest channel the body has for receiving information about the world. The deepest past sometimes finds its way to the present, not through the mind, but through something older than the mind. The novel viruses of the Tibetan permafrost belong to a silence that science is only beginning to learn how to listen to. The ice cores drilled from the Gulia ice cap, some of the oldest recoverable ice on the Tibetan plateau, contained genetic material from viruses belonging to families so distant from anything in current databases that the researchers who analyzed them could not place them within existing classification systems. 28 distinct viral populations were identified in cores from the site, and of these, the great majority had no close relatives in any known viral database. They were not merely old versions of familiar viruses. They were genuinely unfamiliar, representing lineages that had evolved, diversified, and been archived in the ice before the ecosystems that currently populate the planet had taken their present forms. Scientists approached these findings with the careful precision appropriate to genuinely novel results, noting what could be confidently said, noting what remained uncertain, noting the limits of current methods for characterizing organisms so different from those the methods were designed to study. What they could say with confidence was this: the frozen record holds forms of life that the living world has not yet encountered. Lineages that evolved in isolation over geological time, preserved in ice and permafrost, waiting in categories that science has not yet built the vocabulary to describe. The living world is larger than the catalogue of the living world. The frozen ground holds the difference. The tundra above permafrost in summer becomes something that asks you to simply look at it for a while, not analyze, not identify, simply look. Across the wet, polygon-patterned, water-threaded landscape, in the long, slanted light of the Arctic summer that arrives at angles too low and too golden for any temperate latitude to replicate, the tundra in July has a quality of illumination that photographers and researchers and travelers return to describe with a consistency that suggests they are trying to convey something real and specific rather than merely personal. The light comes from a sun that never fully sets, that circles the horizon rather than crossing it, casting shadows that move slowly around objects rather than shortening and lengthening through the day. The water in the thermocast ponds catches this light and holds it, pooling gold among the green of the sedges and the white of the cotton grass. The tundra does not look ancient from a distance. It looks alive, immediate, present, full of the particular vitality of a place that has only a few weeks to accomplish what other landscapes accomplish across an entire year. And below all of it, below the living surface, below the active layer with its roots and its insects and its pooled summer water, the permafrost continues, cold and still and patient, holding everything it has always held, while the world above it briefly, brilliantly, blooms. The oldest ground on Earth spends its summers wearing the most vivid possible surface of the present. The ice wedges of the permafrost have been keeping time in a way that no clock was designed to keep it. Each winter, as the ground contracts in the deep cold and cracks open along lines of weakness, a thin film of water enters the crack and freezes, adding a layer to the ice wedge that has been growing in that location since the crack first formed, perhaps thousands of years ago. Each layer is a winter. Each winter is a layer. Scientists who cut cross-sections through ice wedges and examine them under polarized light see the individual layers as distinct bands, each one a different crystal orientation, each one corresponding to a specific year, a specific season, a specific moment of cold that has not existed since it passed. The oldest ice wedges contain thousands of these layers, thousands of individual winters preserved in sequence, a chronological record of cold, so precise and so continuous that it constitutes one of the longest unbroken records of seasonal events available anywhere in the cryosphere. And the wedge is still growing. Right now, in the deep Arctic winter, the ground is contracting, the cracks are opening, the water is entering and freezing, and this year's winter is adding its layer to a structure that was already ancient when the first human civilization began to keep its own records of time. While we have been counting years, the frozen ground has been keeping every one of them in ice without being asked. The boreal forest, the largest land ecosystem on Earth, grows above permafrost that most of its trees have never touched. The great taiga stretching across Russia, Canada, and Scandinavia, the vast belt of spruce and pine and larch that encircles the northern part of the planet and contains more standing wood than any other terrestrial biome, grows in soils that sit, in large portions of its range, directly above permafrost. The roots of these trees reach down through the active layer and stop at the frozen boundary below, unable to penetrate the ice, constrained to whatever depth the summer thaw allows. In some areas, this means the trees are rooted in only a meter or less of unfrozen soil, balanced above an ancient frozen layer that their roots will never reach, drawing their water and their nutrients from the thin active zone between the frozen ground and the open air. The trees are enormous, in some cases centuries old, but their roots are shallow, wide-spreading networks designed for a world with a floor. The permafrost is that floor. It has been there for the entire life of every tree above it, for the entire history of the forest communities that have grown above it, silent and cold and determining, in ways the trees above have no awareness of, the precise conditions of the world in which those trees have grown. The oldest foundations are the ones that support the most life while remaining entirely invisible to it. A permafrost core drilled with care and kept frozen during its entire journey from field to laboratory arrives, carrying something that the scientists who receive it handle with an awareness that goes beyond the professional. The object in their hands contains time so compressed, so physically present, so completely unlike any other kind of record, that the experience of holding it occupies a different category from the experience of handling other scientific samples. Colleagues who work with permafrost cores consistently describe, when asked, a particular quality to the first moment of receiving a new core, a stillness in the room, a collective pause, a moment in which the knowledge of what is being held becomes, briefly, overwhelming, not in an alarming way, but in the way that genuine scale always is when it is felt, rather than merely understood. Each centimeter of the core represents centuries. The entire core, which fits in human arms, may span more time than our species has existed as a recognizable form. The people holding it are the first beings with the capacity to understand what they are holding, who have ever been in contact with the material within it. Everything that has touched it before was the cold itself, and the sediment, and the organisms sealed within it, none of them aware of what they held. Now something aware is holding it, for the first time, reading it with instruments designed for exactly this purpose, in a moment that the permafrost did not know it was waiting for, but that it was, in every physical sense, ready for. To hold deep time in your arms is to feel, briefly, what it means to be the part of the universe that understands itself. The mammoth steppe, the ecosystem that the permafrost preserves most abundantly, was among the most productive grasslands the Earth has ever sustained. Stretching across what is now Siberia, Alaska, and the land between them that the lower sea levels of the Ice Age kept above water, the mammoth steppe was a cold but extraordinarily productive ecosystem, dominated by grasses and herbaceous plants, supporting populations of large mammals at densities that the modern tundra and boreal forest cannot approach. Woolly mammoths, woolly rhinoceroses, cave lions, giant deer, steppe bison, cave bears, horses, species that represented an ecological richness now found only in the African savanna, distributed across the northern latitudes of the planet, in an era when the cold, counterintuitively, supported more large animal biomass than the warmer ecosystems that replaced it. The permafrost holds this ecosystem in suspension, not as a description of it, not as a fossil record of its shapes, but as its actual biological material, the actual soil microbiome, the actual plant remnants, the actual animal tissue, all of it still present, still chemically analyzable, still yielding information about how the ecosystem functioned, what it was made of, what made it possible. The world was once different in a way that the permafrost has kept available for study. The mammoth steppe is gone from the surface, but it is not entirely gone. Some lost worlds are not lost. They are stored, waiting in the cold for the questions that will bring them back, partially, into the light. The Svalbard Global Seed Vault, built into a mountain on a Norwegian archipelago deep inside the Arctic Circle, relies on something older than any of the technology within it. The vault was designed and engineered with sophisticated cooling systems, with redundant power supplies, with carefully controlled humidity and temperature management. And beneath all of that engineered precision, beneath the layers of human technological intention, the designers included something that required no engineering at all: the permafrost itself. The mountain into which the vault is built contains permafrost that has been stable for thousands of years, and that permafrost provides, passively and continuously and without any energy input, a layer of cold that would preserve the seeds within the vault, even if every engineered system failed simultaneously. It is a backup written in geology, a redundancy provided not by human ingenuity, but by the same patient cold that preserved the mammoth and the cave lion, and the ancient flower and the sleeping bacterium, now extended, without modification, to the seeds of thousands of plant varieties that humanity has cultivated across 10,000 years of agriculture. The oldest cold on Earth is now formally enrolled as a guardian of the future of human food. The permafrost did not apply for the position. It was simply cold, reliably, in the right place, at the right depth, for long enough to qualify. The most reliable guardian is sometimes the one that has simply been there, doing the same thing, for the longest time. Batch 10 Facts 91-100 plus wind down. Where the ice wedges of permafrost finally melt, the geometry of thousands of years dissolves into water. The polygonal patterns that freeze and thaw cycles pressed into the tundra surface across millennia, those vast geometric networks of raised rims and settled centers that aerial photographers once mistook for ancient earthworks, depend entirely on the ice wedges beneath them for their form. When warming reaches the wedges and the ice within them begins to melt, the wedge walls collapse inward, the rims subside, and the geometry that took 10,000 winters to build fills with water in a single summer. The troughs where the wedges ran become channels. The channels fill and connect. The polygon centers, now lower than the surrounding landscape without the wedge ice to support the ground beside them, become ponds. And the ponds connect to other ponds, and the ponds expand, and what was once a geometric pattern of solid ground becomes a landscape of water, dark and still and quietly bubbling with the methane of awakened microbes. The transformation is irreversible on any human timescale. The ice wedge that took 10,000 years to grow cannot be regrown in any period meaningful to a human life. What the cold built slowly, the warmth undoes, and the landscape rearranges itself into something new, something that has its own beauty, its own ecological logic, its own particular relationship to light and water and sky, but is no longer what it was. The geometry is gone. The ponds remain. What patience builds across millennia, change can undo in a season. Both the building and the undoing are real. Beneath the permafrost, in the zone where frozen ground gives way to the warmer earth below, something persists that has no precise equivalent in any other environment, the talik. A layer or pocket of unfrozen ground existing within or beneath the permafrost, insulated from the cold above by the frozen layer and from the heat below by the distance from the Earth's interior, maintaining liquid water in a location surrounded on multiple sides by ice. Taliks form where the conditions conspire to prevent freezing despite the proximity of permafrost, beneath deep lakes whose thermal mass prevents the ground below them from ever fully freezing, along groundwater pathways where moving water carries enough heat to maintain a corridor of liquid within the frozen matrix, in locations where the geometry of the permafrost creates pockets sheltered from the cold on all sides. Within these taliks, liquid water moves slowly through unfrozen sediment, carrying dissolved minerals and gases, supporting microbial communities that do not have the extreme cold adaptations of the permafrost microbes because they have never needed them. They live in a room temperature world, in geological terms, surrounded by ice on all sides, sustained by the particular geometry of the frozen ground around them, in a habitat that exists only because the permafrost creates the conditions for an exception to itself. Life finds the talik the way it finds every other habitable fraction of the world, quietly, efficiently, without announcement, simply by being there when the conditions allow. Life does not wait for perfect conditions. It moves into every imperfect one that will sustain it. The ancient pollen, under the flower pigments of the Pleistocene tundra, hold colors that no living eye has seen in their original context. Blues and purples and pale yellows from flowers that bloomed across the Mammoth steppe in seasons that have not recurred since the Ice Age ended, preserved in the permafrost with a fidelity that extends beyond shape to include the actual molecular compounds responsible for the color. Pigment molecules, which are among the more chemically fragile biological structures, have survived in permafrost conditions long enough for scientists to identify them, to determine which chemical pathways produced them, to compare them with the pigments of related species still living today, and note where they diverge and where they correspond. The flowers they came from are gone. The ecosystems that selected for those particular colors, that particular relationship between petal chemistry and the eyes of the pollinators that once visited them, are gone. But the colors themselves, in the form of the molecules that carried them, are still present in the frozen ground, still analyzable, still telling the story of a floral display that occurred in a world no living human has ever seen. 10,000 years after the last of those flowers opened, their color is still there, waiting in the permafrost, for someone with the right instruments to come and ask what shade of blue the Ice Age wore in spring. The world keeps its colors longer than it keeps anything else we think of as beautiful. The coastlines of the Arctic are retreating in a way that is quiet from a distance and immense up close. Where permafrost meets the sea, the combination of warming ocean water and the mechanical force of waves against frozen bluffs produces a rate of coastal erosion that researchers who study it describe as among the most dramatic landscape change currently occurring anywhere on Earth. Bluffs that have stood in their present form for thousands of years, that held their position through the entirety of human civilization, are now retreating at rates measured in meters per year in some locations, the permafrost that provided their structural integrity, softening at the base as the ocean delivers heat from below, while the atmosphere delivers it from above. Communities in Alaska and Siberia that were built on permafrost ground near the coast are relocating, moving away from shores that can no longer be trusted to remain where they were when the buildings above them were constructed. The retreating cliffs release, as they fall, everything the permafrost held within them: the ancient carbon, the preserved organic material, the biological record of thousands of years of Arctic ecology, all of it entering the ocean in a single tide, beginning the decomposition that the cold had held in suspension, rejoining the cycles of the living ocean after millennia of frozen keeping. The shore is moving. The record, at those edges, is ending. What falls into the sea is not lost. Exactly. It is simply released, finally, from the archive into the present. Every archive has edges, and at the edges, the past returns to the world it came from. Even the lightest presence on the tundra leaves a record in the frozen ground below. A single person walking repeatedly across the same path on Arctic tundra compresses the living moss and lichen that insulates the permafrost below, reducing the thickness of the insulating layer by a small but measurable amount, allowing heat to penetrate more deeply into the ground than it would through undisturbed vegetation. Over time, this thermal change propagates downward into the permafrost, leaving a thermal signature in the frozen ground that persists for years after the walking has stopped. Researchers who study this effect do so with instruments sensitive enough to detect the difference between ground that has been walked on and ground that has not, even when the surface vegetation appears to have recovered and no visual evidence of disturbance remains. The permafrost remembers the footstep long after the foot has gone. This is not a reason for paralysis, not a cause for alarm, simply a fact about the sensitivity of the frozen ground to the world above it and the time it takes to absorb and then release the thermal information encoded in even the lightest human contact. Even as you rest right now, far from any tundra, the ground in the north is reading the accumulated thermal record of every step taken above it, responding to the human presence it has received, slowly, in the language of temperature, in a ledger that takes decades to process a single entry. The most delicate environments keep the most complete accounts of everything that passes through them. The stillness of the deepest permafrost is not a quality imposed on it from outside. It is what the permafrost is, not a temporary condition waiting to be interrupted, not a pause between more active states. The stillness of permafrost at depth is its fundamental nature, the expression of what happens when cold and time act together on biological and mineral material, across spans that exceed the capacity of ordinary imagination to hold. The least disturbed environment on the planet's land surface, colder and more stable than deep ocean sediment in many locations, more thermally consistent than any engineered environment maintained for any comparable duration. Scientists who study it describe returning to this quality of stillness repeatedly, as though the permafrost keeps offering it as a kind of gift to whoever is paying close enough attention. Not a dramatic stillness, not an empty stillness, a full, patient, ancient stillness, the kind that belongs to something that has been doing the same thing for so long that the doing and the being have become indistinguishable. The permafrost does not try to be still. It simply is still, because stillness is what tens of thousands of years of cold, maintained consistently, produces in the end. It is what time looks like when it has been given enough of itself to become completely what it is. The deepest stillness is not achieved. It is accumulated, one cold year at a time, until it becomes the nature of the thing itself. To hold a permafrost core is to experience something that language was not quite built to describe. Scientists who work with these samples return to this admission with a frequency that is itself informative. They have the vocabulary of their discipline, the precise terminology of cryosphere science, the exact language of isotopes and stratigraphy and paleoecology, and still, when asked to describe the experience of holding a core that spans 100,000 years, they tend to reach past their professional vocabulary towards something more personal, more embodied, more honest about the limits of language when confronted with scale that exceeds what language was designed to handle. The vertigo they describe is real. The object in their arms is genuinely outside the categories that ordinary experience provides tools for. It is too old to feel old in the way that old things usually feel old. It is too full to feel like something that has been waiting. It is too physical, too present, too cold and solid and immediate to feel like the past, and yet it is nothing but the past, compressed into something that the arms can hold, brought into the present by the simple act of drilling and lifting and keeping cold during transit. The scientists hold it, they feel the weight of it, and they understand, in that moment, that what they are holding is not a sample of time, it is time itself, in its most physical possible form, briefly in contact with the present. When time becomes an object you can hold, the distance between past and present briefly disappears. Right now, as you rest, the frozen ground in the north is doing what it has always done, not waiting, not pausing, not suspended between states, simply being what it is, cold and still and full, in the darkness beneath the tundra, beneath the taiga, beneath the Arctic Ocean floor, beneath the high mountain meadows where altitude provides what latitude cannot. The permafrost is not aware of you. It is not aware of anything. It has no awareness to offer, no attention to direct toward the world above it, no capacity to know that it is being thought about, that someone is lying still in a warm place far from any tundra and thinking about what is frozen in the ground to the north. It simply continues. The bacteria in their nanometer-thin films of almost water continue their imperceptible movements. The ice wedges hold their patient geometry. The ancient pollen rests in its layers. The mammoth hair retains its pigment. The cave lion sleeps in its posture. The ancient seeds hold their possibility. The carbon waits in its frozen abundance. All of it continues, in the dark, in the cold, in the silence that has no equivalent in any warmer place, doing exactly what it has always done, which is to hold, and to keep, and to be still, and to be there, in the vast quiet of the frozen north, exactly as it has been for longer than our species has had the words to describe it. The world has been keeping things safe for a very long time. It is keeping things safe right now. The permafrost is thawing at its edges, slowly, and as it does, it is telling its story for the first time. For all the time it has existed, the permafrost has been silent, in the sense that matters most. Its contents have been sealed, its record has been closed, its carbon has been held, its organisms have been paused, its story has been kept entirely within itself, unavailable to the world above, except through the slow geological processes by which permafrost eventually gives way to other forms of ground. Now, at its edges, where the warming has reached deeply enough and persistently enough, the archive is beginning to open. Carbon enters the atmosphere. Microbes resume their ancient metabolisms. Clutter, ice wedges, release their held geometry into water. Coastlines give back to the sea what the sea gave up to the land during the Ice Age. And scientists read what is released, carefully, urgently, aware that the opening of the archive is also, in some places, its destruction, that the story being told is being told in the act of ending that the most complete access to the permafrost record will coincide with the conditions that make it irreplaceable in a new and different way. The permafrost kept its story for 40,000 years. It is beginning, now, at its margins, to speak. The speaking is slow. It will continue for a long time, and what it says, if we are patient enough and careful enough to listen, is everything that the cold has held, offered back, finally, to the world that made it. The oldest archives do not announce when they begin to open. They simply, slowly, start to release what they have held. And now, as this long night of wondering gently closes, let the facts recede, and let only the feeling remain. You have been traveling, in the quietest possible way, through something ancient, beyond the reach of any ordinary imagination. Not through space, not through the visible drama of stars and galaxies, but downward, into the ground, into the cold, into the patient dark, where the world has been keeping its most faithful records. The permafrost does not know you are thinking about it tonight. It does not know you exist. And yet, something in the act of knowing it, of letting its reality settle into your awareness, creates a connection that is real, even if it runs only in one direction. Right now, as your body rests and your breathing slows, the frozen ground in the north is exactly as cold as it was last night. The bacteria, in their nanometer-thin films, are moving at speeds too slow for any instrument you will ever hold to detect. The ice wedges are holding the shape of 10,000 winters, quietly, in the dark. The ancient pollen rests in its layers. The mammoth hair keeps its color. The seeds hold their possibility within them, patient, without urgency, without any awareness of how long they have been waiting. The world is older than you need it to be, and colder, and more patient, and more full of kept things than any library we have ever built. It has been holding its breath since before your species learned to breathe, and it is still holding it, gently, in the frozen north, while you rest here in your warmth. Let that oldness settle around you now, not as weight but as something closer to shelter. You are part of a world that knows how to keep things. That has always known. That kept the flower and the cave lion and the ancient seed and the sleeping bacterium and the breath of the Ice Age atmosphere. Not because it intended to, not because it was asked to, but simply because the conditions were right, and the cold was patient, and time did what time does when nothing disturbs it. Your breath is warm. The frozen ground is cold. Both belong to the same world. The same physics made them both. The same universe holds them both, right now, simultaneously, without contradiction, without difficulty, as naturally as the tundra holds its summer ponds and its winter ice and its ancient stillness all in the same place, across the same geological time, without any sense that these things are in conflict. The permafrost will be there in the morning, cold and full and patient and ancient, holding what it holds, being what it is. You will wake to a world that has been keeping itself while you slept, the way it has always kept itself, the way it kept the mammoth and the flower and the sleeping microbe, gently, without effort, simply by being the world. Rest now. Let the cold ground hold what it holds. Let the ancient dark be ancient and dark, far to the north, while you are warm, here, in this moment, which is its own kind of keeping. The frozen world is patient. It has time, and so do you. I hope you sleep well and dream softly. Good night.